What if the objects that zip through our solar system aren't just random space debris, but mysterious visitors from distant star systems, carrying secrets from beyond our own cosmic neighborhood? Imagine a rock from another galaxy passing right through our solar system, silent, strange, and completely alien. One of these objects, Oumuamua, sparked a firestorm of theories when it passed by in 2017, and it's just the beginning. What are these interstellar travelers really, and what can they tell us about the universe outside our solar system? Let's dive into the mysteries of these incredible space wanderers. Something came from deep space. It wasn't a planet, it wasn't a comet, and it wasn't an asteroid, at least, not like any we've ever seen before. It was the first interstellar visitor in recorded history, and it left scientists absolutely baffled. It moved in ways that made no sense, had a shape that defied explanation, and then, before anyone could get a clear answer, it disappeared. That was Oumuamua, an object so strange that even top scientists considered the possibility that it wasn't natural at all. And here's the craziest part, Oumuamua wasn't alone. Just a couple of years later, another interstellar object arrived, Comet Borisov. Unlike Oumuamua, Borisov looked more familiar, like a typical comet, but it confirmed something incredible. Our solar system isn't isolated. Objects from the depths of space are passing through all the time, and we barely even notice. But what are these things? Where do they come from? And why was Oumuamua so different from anything else we've ever seen? Some believe it was just a weird chunk of rock, but others aren't so sure. Could it have been an alien probe? A fragment from a distant star system? A piece of something even more bizarre? And if interstellar objects are so common, how many have already come and gone without us noticing? To understand just how strange these space visitors are, we need to break down everything we know, everything we suspect, and everything we still have no clue about. Because the mystery of interstellar objects isn't just about two random space rocks. It's about the possibility that our solar system is just one small stop in a much larger, much weirder cosmic journey. Let's start with Oumuamua, the object that changed everything. Before 2017, we had never seen anything like it. Every asteroid, every comet, every space rock we had ever tracked came from inside our solar system. But then, in October of that year, astronomers in Hawaii noticed something strange. A fast-moving object was racing through our solar system at an incredible speed, and its trajectory made no sense. Unlike planets and asteroids that orbit the sun in predictable loops, this thing was on a hyperbolic trajectory, meaning it wasn't just passing through, it was leaving, never to return. Right away, scientists knew they had found something special. If it wasn't orbiting the sun, that meant it had to have come from somewhere beyond our solar system. It wasn't bound to the sun's gravity like everything else. It was a visitor, traveling across the galaxy. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar. And the more they studied it, the weirder it got. First, there was its shape. Most asteroids and comets are lumpy, irregular blobs, but Oumuamua was different. Observations suggested it was long and thin, possibly shaped like a cigar or a flattened pancake. It was unlike anything in our solar system, and that was just the beginning. Then came the movement. As Oumuamua sped away from the sun, something bizarre happened. It accelerated. That shouldn't have been possible. Objects in space follow the laws of physics, and an object like this should have slowed down as it moved away from the sun's gravity. But it didn't. Instead, it sped up, as if something was pushing it. Normally, when a comet gets close to the sun, it releases gas and dust, creating a tail that can push it forward. But Oumuamua had no visible tail, no outgassing, nothing that could explain why it was accelerating. That left scientists scrambling for answers. Was it a chunk of hydrogen ice, slowly evaporating in a way we couldn't detect? Was it a thin sheet of material, pushed by the faint pressure of sunlight? Or, as some suggested, was it something even stranger, like an artificial object, possibly a probe sent by an advanced civilization? That last theory might sound crazy, but it came from some serious scientists. Harvard astronomer Avi Loeb argued that Oumuamua's unusual acceleration and shape could mean it was a type of light sail, an ultra-thin spacecraft designed to be propelled by starlight. If true, that would mean we had just witnessed an alien artifact passing through our solar system. Of course, not everyone agreed. Many scientists believed Oumuamua was natural, just an unusually shaped rock that happened to behave in unexpected ways. But with only a brief window of time to study it, we may never know the full truth. By early 2018, Oumuamua was too far away to observe, vanishing into the darkness of space forever. But just when scientists thought they might never see another interstellar visitor, it happened again. In 2019, a new object was spotted, and this time, it was unmistakably a comet. Unlike Oumuamua, which had no visible tail, Comet Borisov looked like a classic comet, with a bright coma and a trailing stream of gas and dust. Named after the amateur astronomer who discovered it, Gennady Borisov, this new interstellar visitor had an origin as mysterious as Oumuamua. It was traveling at speeds that meant it couldn't have come from our solar system, confirming that interstellar objects weren't just a one-time event. But Borisov, despite being more familiar in appearance, raised its own questions. Why did it look so much like our own comets if it came from a completely different star system? Did that mean comets everywhere in the galaxy form in similar ways? And if interstellar objects are so common, how many have already passed through without us noticing? These discoveries have forced scientists to rethink everything they thought they knew about how solar systems interact. For billions of years, material has been ejected from different star systems, drifting through space, occasionally making brief visits to other stars. That means the objects passing through our solar system could carry clues about the history of alien star systems, and maybe even hints about life beyond Earth. And here's the most exciting part: we're just getting started. With new telescopes and better technology, scientists expect to find many more interstellar objects in the coming years. Some could be ordinary rocks, others could be more mysterious. And if one day, we detect something that doesn't just look natural but actually shows signs of intelligence, well, that would change everything. The mystery of interstellar objects is far from solved. In fact, we're only at the beginning. The universe is full of visitors, and the more we watch, the more we might discover. So the real question isn't just what Oumuamua and Borisov were, it's what else is out there, waiting to be found. If Oumuamua and Borisov are just the first interstellar objects we've noticed, how many more have passed through our solar system without anyone realizing? The truth is, for most of history, we simply weren't looking. Space is vast, and objects moving through it don't glow or announce themselves. They're just small, fast-moving specks in the endless darkness. Our telescopes have only recently become advanced enough to detect them, and even then, we barely caught Oumuamua before it was gone. But if we assume that interstellar objects are common, then logic tells us that there could be hundreds, thousands, or even millions of them passing through over time. Some could be just like Borisov, icy comets flung from their home star systems. Others could be like Oumuamua, strange, thin, fast-moving objects that don't behave like anything we've ever seen. And if the most extreme theories are right, some of these objects might not be natural at all. One of the biggest challenges in studying interstellar objects is that they move incredibly fast. Oumuamua, for example, was traveling at about 315,000 kilometers per hour, 196,000 miles per hour. That's faster than anything in our solar system, and it's the reason why it didn't get trapped by the sun's gravity. It came in, it passed through, and then it left, on a path that will take it out into the vast emptiness of interstellar space. Because of this, catching an interstellar object early is crucial. The sooner we detect one, the more time we have to study it. That's why astronomers are pushing for better sky surveys, more advanced telescopes, and even space missions that could one day intercept and study these objects up close. Imagine a spacecraft designed to chase down an interstellar visitor, sending back high-resolution images and data. That might sound like science fiction, but it's something scientists are already discussing. But what if we don't need to chase these objects? What if one of them actually hits Earth? Could an interstellar meteor ever collide with our planet? Surprisingly, there's some evidence that this might have already happened. In 2014, an object exploded over Papua New Guinea. At first, it seemed like an ordinary meteor, the kind that burns up in Earth's atmosphere all the time. But years later, scientists analyzed its speed and trajectory and realized something shocking. It was moving so fast that it had to have come from outside our solar system. If true, that would mean it was the first known interstellar object to ever hit Earth. And here's where it gets even crazier. Some of the fragments from that meteor may still be on the ocean floor, waiting to be recovered. Harvard's Avi Loeb, the same scientist who suggested Oumuamua could be an artificial object, led an expedition to search for these fragments. His team dredged the seafloor and found tiny metallic spheres that might have come from an interstellar source. If they really did, then these tiny particles could hold secrets about the chemistry of other star systems. Or, in the most extreme scenario, they could be debris from something artificial. Of course, this is all still speculative, and many scientists remain skeptical. But the idea that interstellar objects are not only passing through but actually colliding with our planet raises a huge question. How many times has this happened before? Could pieces of alien worlds be sitting on Earth, mistaken for ordinary space debris? And if an interstellar object ever posed a real threat, say, an asteroid on a collision course, would we even have time to stop it? The more we learn about interstellar objects, the more we realize how little we actually know. Just a decade ago, no one had ever seen one. Now, we've found multiple candidates, and there's no reason to think we won't find more. Each discovery brings new questions, new mysteries, and new possibilities that push the boundaries of what we understand about our place in the universe. If Oumuamua had been slightly different, if it had lingered a little longer, or if it had emitted some kind of signal, our entire view of the cosmos might have changed overnight. Instead, it remains an enigma, an unsolved mystery that forces us to keep looking, to keep asking questions, and to keep wondering what else might be out there. And that's the real mystery of interstellar objects. They are cosmic messengers, reminders that our solar system isn't isolated, that the universe is in constant motion, and that something is always passing through, whether we notice it or not. The only question is, what will we find next? The search for interstellar objects is only just beginning, and the technology we have today is barely scratching the surface of what we could discover in the future. As telescopes become more advanced and our ability to track fast-moving objects improves, we may soon enter an era where interstellar visitors are detected frequently, perhaps even several times a year. But that raises an even bigger question. If these objects are so common, what exactly are they? One possibility is that they are simply fragments from other star systems, pieces of planets, asteroids, or comets that were ejected by powerful gravitational forces. In a way, these objects could be the space debris of the universe, flung from their home systems after close encounters with massive planets or passing stars. But if that's true, why did Oumuamua behave so strangely? Unlike Borisov, which was a classic comet with an icy tail, Oumuamua didn't leave behind any visible gas or dust. This lack of a cometary tail is one of the reasons why scientists struggled to classify it. It was tumbling end over end, and its brightness changed rapidly, suggesting it was a long, thin, possibly flat object. Some scientists even suggested it might be a shard of a broken planet, perhaps a fragment of a rocky world that was destroyed in some cosmic catastrophe billions of years ago. But then there's the even wilder theory, the idea that Oumuamua was not a natural object at all. This idea was made famous by Avi Loeb, who proposed that Oumuamua might be an artificial object, possibly a defunct alien probe or a piece of interstellar technology drifting through space. While many scientists dismiss this theory as unlikely, the fact remains that we don't know for sure what Oumuamua was. It didn't behave like anything we'd ever seen before, and without more data, we may never get a definitive answer. This brings us to the real challenge of studying interstellar objects. We see them only briefly, and by the time we realize they're unusual, they're already on their way out of the solar system. If we ever want to truly understand these objects, we need a way to study them up close. That's why some scientists are proposing a mission to intercept an interstellar object, either by sending a probe to a future visitor or even designing a spacecraft that could chase down Oumuamua itself. It might sound impossible, but in theory, a mission to intercept an interstellar object could be achievable with current technology. The key is early detection. If we spot an object far enough in advance, we could launch a spacecraft that could either observe it from a distance or even land on it to collect samples. Imagine what we could learn from studying an object that originated from another star system, analyzing its composition, its structure, and perhaps even uncovering signs of organic molecules or something even stranger. But beyond the scientific curiosity, there's another reason why interstellar objects are so important. They might hold the key to understanding how life spreads through the universe. Some scientists believe that life on Earth may have originated from space, carried by comets or asteroids that crashed into our planet billions of years ago. If interstellar objects carry the building blocks of life, then they could be seeding planets across the galaxy, spreading life from one system to another. This idea, known as Panspermia, suggests that life might not have started on Earth at all. It may have arrived here from elsewhere. And if that's true, then every interstellar object that passes through our solar system could be carrying the potential for life with it. Could there be frozen bacteria or organic molecules trapped inside these objects? Could the seeds of alien life be drifting through space, waiting to find a new home? We don't have the answers yet, but as we continue to study these objects, we may uncover evidence that changes our entire understanding of life and the universe. For now, though, the best we can do is keep looking, scanning the skies, improving our technology, and hoping that the next interstellar visitor arrives soon enough for us to study it properly. Because if Oumuamua was just the first, and Borisov was just the second, then it's only a matter of time before we find something even more extraordinary. And when that happens, we need to be ready. The biggest challenge in studying interstellar objects is that they move fast, really fast. By the time we notice them, they're often already speeding away from us, making it nearly impossible to send a spacecraft to investigate. This is why scientists are now working on ways to detect these objects earlier. The Vera C. Rubin Observatory, expected to begin full operation soon, will play a key role in scanning the sky for new objects. With its advanced wide-field telescope, it could detect interstellar visitors much sooner than ever before, giving astronomers more time to study their trajectories and predict where they're headed. But simply detecting these objects isn't enough. To truly understand them, we need to get up close. Some researchers have proposed sending a spacecraft that could launch as soon as an interstellar object is detected, racing to intercept it before it leaves our solar system. A project known as the Interstellar Probe, currently under discussion, could be designed specifically for this purpose. It would be equipped with high-speed propulsion systems, allowing it to chase down these fast-moving objects and collect detailed data on their composition, shape, and possibly even their origins. If we ever manage to intercept one of these objects, the information we gather could be groundbreaking. Imagine finding minerals that don't exist in our solar system, or detecting isotopes that point to a different kind of planetary formation. What if we found organic compounds, amino acids, the building blocks of life, on an object that came from another star system? That would be one of the most profound discoveries in human history, as it would suggest that the basic ingredients for life are scattered throughout the galaxy. And then there's the even more extraordinary possibility. What if one of these objects isn't natural at all? The idea that Oumuamua could have been an artificial object was met with skepticism, but it opened up an important discussion. If an advanced civilization were sending probes through space, looking for other life forms, those probes might not stop to visit each star system. Instead, they might pass through quickly, gathering data as they move, much like how we send spacecraft to fly past distant planets. If this were the case, spotting such an object would be a once-in-a-lifetime opportunity. But the problem is, unless we act fast, we may never know for sure. Oumuamua was here and gone before we could properly analyze it, and the same thing could happen with future interstellar visitors. That's why the push for better tracking and faster space missions is so important. If we can prepare now, we might one day be able to catch one of these objects in time to unlock its secrets. The question isn't whether another interstellar object will come, it's when. Scientists are confident that many more are out there, waiting to be discovered. Some may be simple chunks of rock and ice, while others could be completely unlike anything we've seen before. We just need to be ready for the moment one enters our solar system. Imagine a future where we don't just observe interstellar objects, we reach them, study them, and perhaps even bring samples back to Earth. The knowledge we could gain from this would be revolutionary, giving us clues about the formation of other planetary systems, and possibly even the spread of life across the galaxy. If interstellar objects really do carry the building blocks of life, then each new discovery brings us closer to answering one of humanity's biggest questions: are we alone? Until then, all we can do is keep searching. The universe is vast, and objects like Oumuamua and Borisov are just glimpses of a much bigger story. What else is out there, drifting silently through space, waiting to be found? The answer could be stranger than anything we've imagined. If the next interstellar object is even more unusual than Oumuamua or Borisov, it could change everything we think we know about the cosmos. The more we look, the more we realize that space isn't just empty, it's filled with countless mysteries, waiting to be uncovered. And when we finally get the technology to study these objects up close, we might discover things that challenge the very foundation of our understanding of the universe. One of the biggest mysteries surrounding interstellar objects is their origin. Where do they come from? How do they get ejected from their home star systems and sent hurtling across the galaxy? Scientists believe that powerful gravitational interactions, such as a close encounter with a massive planet or even a binary star system, could fling an object out into interstellar space. Once it's free, it drifts endlessly, passing through different star systems, possibly for billions of years. But there's another possibility. What if some of these objects are deliberately sent? If an advanced civilization exists somewhere in the galaxy, it might launch probes into space, sending them on long journeys to explore the cosmos. These probes wouldn't necessarily slow down when passing through a solar system. They could be designed to gather data and transmit it back to their creators. If we ever found an interstellar object that showed clear signs of artificial construction, it would be the greatest discovery in human history. Even if none of these objects turn out to be alien in origin, studying them could still teach us a lot about the conditions of other star systems. By analyzing the composition of these objects, we could learn what materials exist elsewhere in the universe, and how they compare to those in our own solar system. Are the same elements and minerals found throughout the galaxy, or are there materials we've never seen before? And then there's the question of how these objects interact with the environments they pass through. Do they pick up materials from different star systems? Could they serve as messengers, carrying elements and compounds from one world to another? If an interstellar object entered our solar system carrying frozen water, organic molecules, or even microbial life, it could provide new evidence for the idea that life spreads between planets through space. This is why so many scientists are pushing for missions that could intercept and study these objects in detail. One proposal, known as the Breakthrough Starshot-inspired interstellar probe, suggests using advanced propulsion systems to send a spacecraft toward an interstellar object as soon as it's detected. This probe could take close-up images, analyze the object's surface, and even deploy small landers to collect samples. The challenge, of course, is speed. These objects move incredibly fast, and catching up to them requires technology far beyond what we currently have. But advancements in propulsion, including solar sails, nuclear propulsion, and even theoretical concepts like laser-driven spacecraft, could eventually make it possible. If we can develop the ability to chase down these interstellar visitors, we could unlock secrets that have been drifting through space for billions of years. But what if we didn't have to chase them at all? Some scientists are considering a different approach. Instead of trying to intercept an object once it arrives, what if we positioned spacecraft in advance, waiting for one to pass by? By placing monitoring stations at the edges of the solar system, we could be prepared to study any incoming interstellar object in real time. No matter which approach we take, one thing is clear: interstellar objects represent a new frontier in space exploration. They are visitors from beyond our solar system, carrying messages from distant worlds, whether those messages are in the form of raw materials, frozen water, or something even more profound. If we ever find an object that contains evidence of life, whether microscopic organisms, complex organic molecules, or something even stranger, it could confirm that life is not unique to Earth. It could prove that life exists elsewhere in the universe, or that it once did. It might even suggest that life can survive the harsh conditions of space, drifting from one system to another. We are only at the very beginning of this journey. Oumuamua and Borisov were the first confirmed interstellar visitors, but they won't be the last. With new technology and better detection methods, we may soon discover that interstellar objects are far more common than we ever imagined. And when the next one arrives, we need to be ready, because the mysteries it carries could change everything. If we look at history, every time humanity has expanded its ability to observe the universe, we've made groundbreaking discoveries. The telescope allowed us to see planets and moons in greater detail, revealing that Earth was not the center of the cosmos. Space probes gave us close-up images of distant worlds, proving that other planets have complex atmospheres, liquid oceans, and even the potential for life. Now, with interstellar objects, we are at the brink of another major shift in our understanding of the universe. We know that Oumuamua was different from anything we've ever seen before. It didn't behave like a typical asteroid or comet, and its acceleration as it exited our solar system still remains unexplained. Some have suggested that it could have been composed of materials we've never encountered, or even that it was shaped in such a way that radiation from the sun caused it to move differently. But the idea that Oumuamua might have been something artificial, a probe from another civilization, has refused to die. The reason this idea remains compelling is simple: we don't fully understand Oumuamua. The unusual way it moved, the lack of a visible tail, and its elongated, flat shape don't match what we would expect from a natural interstellar object. Even if it wasn't an alien probe, its very existence suggests that interstellar objects may not all be the same. The next one we detect could be even more unusual, something so strange that it forces us to completely rethink our assumptions about how objects move through space. Borisov, on the other hand, behaved exactly like a comet, reinforcing the idea that some interstellar objects are simply chunks of rock and ice ejected from other star systems. But even Borisov had interesting differences from comets in our own solar system. Its composition wasn't exactly the same, meaning that planetary systems elsewhere might have slightly different chemical makeups. If we continue discovering more interstellar objects and comparing them, we may be able to identify patterns, perhaps even pinpointing the kinds of star systems they come from. This raises another question. Could some of these objects have been traveling through space for billions of years? If so, they might have originated in completely different parts of the galaxy, maybe even from a time before our solar system existed. Studying them would be like looking at fossils from another era, offering us clues about how planetary systems formed long before ours. And if some of these objects have been drifting for billions of years, could they carry the remnants of ancient, long-extinct civilizations? It sounds like science fiction, but given how little we know about what's out there, we can't rule it out. What if a civilization existed millions or even billions of years ago and sent objects into space that are still traveling today? If one of these interstellar objects turned out to be a piece of technology from an ancient alien race, it would be the single greatest discovery in human history. Even if we don't find anything artificial, the potential for interstellar objects to reshape our understanding of the universe is enormous. Every time one enters our solar system, it brings with it a story, a history of where it has been, what forces have acted upon it, and what materials it contains. Each one is like a message from deep space, waiting to be decoded. But to truly understand these objects, we need to be able to study them up close. Right now, our technology is limited, but future advances in propulsion, artificial intelligence, and space exploration could make it possible to intercept them in real time. If we could land a probe on an interstellar object while it's passing through, we could analyze its materials directly, search for any signs of organic compounds, and even take microscopic samples. The implications are staggering. If interstellar objects are common, then our galaxy is filled with material moving from one star system to another. This means that planetary systems are not isolated. They are part of a much larger network of exchange, where rocks, ice, and possibly even life itself travel between worlds. We are on the verge of a new era in space exploration. Just as the first exoplanets revolutionized our understanding of how common planets are, interstellar objects could reveal the hidden connections between different parts of the galaxy. Each new discovery will bring more questions, but also more clues about the vast and mysterious universe we live in. And one day, if we're lucky, we may detect an object that doesn't just hint at the existence of life beyond Earth, but proves it beyond a doubt. If such a discovery were to happen, it would be the most profound moment in human history. The realization that something, whether microscopic organisms, complex organic molecules, or even artificial structures, originated from another star system and reached us would change everything. It would prove that we are not alone, that life or intelligence has existed elsewhere in the universe, and that the cosmos is far more interconnected than we ever imagined. But here's the real question: would we even recognize alien life if we saw it? What if life beyond our solar system is so different from what we know that we wouldn't immediately understand what we were looking at? Interstellar objects could be carrying forms of life that don't rely on carbon, that don't need liquid water, or that exist in ways we can't yet comprehend. Scientists have long speculated that life might not always be based on the same biological chemistry as life on Earth. Some theories suggest that silicon-based life could exist, thriving in environments that would be completely inhospitable to us. Others propose the idea of shadow biospheres, entire ecosystems of organisms that don't interact with normal biological processes in the way we expect. If an interstellar object carried such life forms, they might not leave behind recognizable biosignatures like amino acids or DNA. We would need to think outside the box, using entirely new methods to detect and understand them. And what if we didn't just find life? What if we found evidence of intelligence? Imagine an interstellar object entering our solar system, behaving in ways that defy natural explanations. It might move with deliberate precision, change direction in ways that can't be explained by gravity, or even emit signals that suggest an intentional design. If we ever encountered an object like that, it wouldn't just be a scientific breakthrough, it would be a moment of reckoning for all of humanity. What would we do next? Would we try to communicate? Would we attempt to follow it, hoping to learn more? Or would we be cautious, wary of the unknown? The answers to these questions aren't simple, but they are questions we may have to face sooner than we think. Even if we never find an interstellar visitor that is artificial or alive, every new discovery helps us refine our understanding of the universe. By studying these objects, we learn more about the formation of planetary systems, the composition of distant worlds, and the forces that shape the galaxy. We gain insight into how common planets like Earth might be, and whether the conditions for life exist elsewhere. It also raises another fascinating possibility. What if Earth itself was once visited by an interstellar object carrying life? Some scientists have proposed that life on Earth may have originated from space, arriving here on comets, asteroids, or interstellar debris. This idea, known as Panspermia, suggests that life could be far more widespread than we think, that it doesn't begin in one place but instead spreads across the cosmos, seeding planets wherever the conditions are right. If this is true, then interstellar objects aren't just visitors, they are messengers, carrying the building blocks of life from one world to another. The next interstellar object we encounter could be carrying those same materials, proving once and for all that life doesn't just emerge on a single planet, but exists throughout the universe. We are living in an incredible time. Just a few decades ago, we didn't even know if planets existed outside our solar system. Now, we've confirmed thousands of exoplanets, and we are beginning to study interstellar objects that come from other star systems. The pace of discovery is accelerating, and with every new breakthrough, we move closer to answering some of the biggest questions of all. Are we alone? Where did we come from? And what else is out there, waiting to be found? The universe is vast, mysterious, and filled with wonders beyond our imagination. But for the first time in history, we have the technology and the knowledge to start uncovering its secrets. The next interstellar object could arrive at any moment. And when it does, we need to be ready, because what it brings with it might change our understanding of reality forever. The search for interstellar objects isn't just about curiosity, it's about survival. If objects like Oumuamua and Borisov are constantly passing through our solar system, how many more have we missed? How many have passed by unseen, simply because we weren't looking in the right place at the right time? And what if, one day, one of these interstellar objects isn't just a harmless rock or an icy comet, but something far more dangerous? Imagine an object hurtling toward us from deep space, something massive, something moving at an incredible speed. If we detected it too late, there would be nothing we could do to stop it. Unlike asteroids from within our solar system, which follow predictable orbits, an interstellar object could appear without warning. It wouldn't be bound by the same gravitational constraints as local space debris, making it harder to track and even harder to predict. This isn't just speculation. Some scientists believe that interstellar impacts have already happened in Earth's past. In 2014, an object known as CNEOS January 8, 2014 entered Earth's atmosphere and burned up over the Pacific Ocean. Initially classified as an ordinary meteor, later analysis suggested it might have originated from outside our solar system. If that's true, then Earth has already been hit by at least one interstellar object. And if it has happened before, it can happen again. But what if we could catch one of these objects before it reaches us? What if, instead of just watching them pass by, we could send a probe to meet one? Scientists have proposed missions that would allow us to intercept an interstellar object while it's still moving through our solar system. Using advanced propulsion systems, we could send a spacecraft to study it up close, taking samples and analyzing its structure. Some even suggest that we could land on one, hitching a ride as it exits our solar system and venturing into interstellar space for the first time. This idea isn't as far-fetched as it sounds. NASA's Voyager 1 and Voyager 2 probes have already left our solar system, traveling through interstellar space right now. The difference is that they weren't designed for this purpose. They were simply flung outward by gravitational forces. If we intentionally launched a mission to follow an interstellar object, we could learn more about the regions beyond our solar system than ever before. And here's the most exciting part. The more interstellar objects we discover, the more we realize just how many of them are out there. Some estimates suggest that at any given time, there may be several interstellar objects within our solar system, objects we just haven't detected yet. The technology to find them is improving rapidly, and in the near future, we may start identifying them regularly. What happens when we detect an interstellar object that doesn't fit any known category? What if we find something that defies all natural explanations? What if, one day, we detect an object that isn't just a rock or a comet, but something far more advanced, something artificial? If we ever receive such a signal, it won't just be another scientific discovery. It will be the moment everything changes. It will be proof that we are not alone. And at that moment, we will have to ask ourselves, are we ready for what comes next? The universe is full of mysteries. But interstellar objects may hold the key to answering some of the most important questions in human history. What are they? Where do they come from? And most importantly, what else is out there, traveling through the vast, dark expanse of space, waiting to be discovered? If we ever found an artificial interstellar object, it would be the biggest discovery in history. The implications would be staggering. It would mean that somewhere out there, another civilization, maybe long gone, maybe still thriving, created something and sent it into the cosmos. Whether it was a probe, a derelict spaceship, or a piece of lost technology, it would prove beyond a doubt that we are not alone. But would we recognize it? What if alien technology looks nothing like what we expect? We imagine spaceships and metallic probes, but what if an advanced civilization designed their technology using biology? What if they grew their spacecraft instead of building them? If an interstellar object were a piece of biotechnology, something that evolved rather than was constructed, we might dismiss it as just another asteroid or comet, never realizing that we had encountered something truly alien. This raises a chilling possibility. What if we have already seen an artificial object and didn't recognize it? What if Oumuamua wasn't just a rock, but something more? Some researchers have suggested that its odd acceleration and strange shape could indicate an artificial origin. What if it was a probe, scanning our solar system before continuing on its way? What if it was a derelict spacecraft, drifting through space for millions of years, long after its creators were gone? And then there's another possibility. What if an interstellar object isn't just passing through? What if one slows down? Imagine the headlines. Unidentified object detected, holding position in our solar system. The scientific world would go into chaos. Governments would scramble to understand what was happening. Could it be an alien spacecraft arriving deliberately? Could it be watching us? Could it be waiting for something? Even if we found an interstellar object with no signs of artificial origin, that wouldn't make it any less exciting. Every rock, every icy body, every strange fragment from another solar system carries a story. It tells us about the conditions in other star systems, about how planets form, about the materials that exist in places we've never seen. These objects are time capsules, frozen records of distant worlds. And that brings us to one of the most mind-blowing ideas of all. what if an interstellar object carried evidence of life? Maybe not alien spacecraft, but the simplest forms of life, bacteria, organic molecules, something that proves that life exists beyond Earth. If we found even a single microbe that originated from another star system, it would change everything. It would mean that life is not rare. It would mean that the universe is teeming with possibilities. But what if we found something even stranger? What if we found an interstellar object that wasn't from a planetary system at all? What if it came from deep interstellar space, from regions between the stars where no planets exist? What kind of forces could create an object like that? Could it be a fragment of a destroyed planet? Could it be something we haven't even imagined yet? Every interstellar object is a clue, a piece of a much larger puzzle. We are only beginning to understand them. The more we study, the more we realize how little we know. And that is what makes them so fascinating. Because with every discovery, we are reminded that the universe is far bigger, far stranger, and far more mysterious than we ever imagined. The truth is, we are only scratching the surface when it comes to interstellar objects. We've had 2 clear encounters with interstellar visitors, Oumuamua and Borisov. But these are only the objects we've managed to detect. Who knows how many more are out there, passing through our solar system unnoticed or undetected. Some researchers suggest that these objects could be a common occurrence, something that happens regularly but goes unseen because we are just beginning to look in the right places. One of the key challenges in detecting interstellar objects is their speed. They move so quickly that they don't hang around long enough for us to catch a good glimpse of them. For example, Oumuamua was moving so fast that it couldn't be captured by the sun's gravity. It passed through our solar system in a flash, and by the time scientists realized it was from another star system, it was already too late to track it closely. This is why, even though these objects are out there, they can be so difficult to detect. But as our technology improves, we're getting better at spotting them. In fact, astronomers have already begun developing new techniques and instruments specifically designed to look for interstellar objects. These advancements could help us catch future interstellar visitors before they zip through our solar system. Telescopes like the Vera C. Rubin Observatory, which will start operating soon, are designed to scan the sky in unprecedented detail, increasing our chances of detecting objects that may have otherwise gone unnoticed. Another approach that's being explored is the use of satellites to detect fast-moving objects in space. The European Space Agency, ESA, is already working on a project called Comet Interceptor, a mission designed to explore a comet from the outer solar system, or even an interstellar comet. It will be launched in 2029 and aims to study a pristine comet that hasn't yet been altered by the sun's radiation. If this mission is successful, it could pave the way for future space missions that focus on interstellar objects. But detection is only the first step. The real mystery lies in understanding where these objects come from and what they tell us about the broader universe. Every interstellar object is like a message from a distant place, carrying with it clues about its origin. The challenge is deciphering that message. Take Oumuamua, for example. It was the first interstellar object we had ever detected, and its strange shape and acceleration sparked a whirlwind of scientific theories. Some astronomers believe that it's simply a natural object, a piece of a larger planetary system that was ejected into interstellar space. Others, however, have proposed that it could be something more unusual, perhaps an alien probe, sent on a long journey across the stars. The truth is, we don't know for sure what Oumuamua was, and this ambiguity only adds to its mystery. Similarly, Borisov, the second interstellar object we detected, was a comet with a more familiar appearance. However, its high speed and trajectory clearly indicated that it came from outside our solar system. Unlike Oumuamua, Borisov didn't exhibit the same strange acceleration, but its discovery still raised intriguing questions about where it came from and how common such objects might be. Now that we know interstellar objects can exist, it raises the question, are these just random visitors, or is there a larger pattern at play? Could these objects be part of a much larger network of objects moving between stars, spreading across the galaxy? Some scientists have even speculated that interstellar objects could be part of a cosmic highway, a series of pathways formed by the gravitational forces of stars that allow objects to travel from one star system to another. If that's the case, it could mean that interstellar objects are not as rare as we once thought. They could be passing through our solar system all the time, without us even realizing it. This idea opens up new possibilities for exploration. If these objects are truly part of a larger network, then we might one day be able to track their paths, predicting when and where they will appear next. This could allow us to send probes or even crewed missions to intercept these objects, exploring them in ways that we've never been able to before. It could also give us a deeper understanding of the forces at work in the universe, from the gravity of distant stars to the strange physics of interstellar space. And it's not just the objects themselves that are intriguing. The fact that we're detecting them means that our view of the universe is expanding. Every time we spot an interstellar object, we're looking into the vast, unexplored regions of space. We're seeing things that have never been observed before, encountering phenomena that challenge our understanding of how the universe works. The more we learn about these objects, the more we realize that there is so much more to discover out there. We are just beginning to peer into the cosmic unknown, and the mysteries of interstellar objects are only the beginning. In the future, we could see missions that not only explore the objects themselves but also the regions of space they travel through. By studying these objects and the space they come from, we might uncover new insights about the formation of stars and planets, the evolution of galaxies, and even the possibility of life beyond Earth. In many ways, studying interstellar objects is like looking at the fingerprints of the universe, traces of ancient events, of collisions and interactions, of the forces that shape the cosmos. For now, the mystery of interstellar objects continues to captivate scientists and the public alike. Each discovery raises more questions than answers, leaving us with a sense of awe and wonder about the vastness of the universe. What are these objects? Where do they come from? What secrets do they hold? As technology improves and we discover more objects from beyond our solar system, these questions will continue to drive our exploration of the cosmos. The universe is full of surprises, and the discovery of interstellar objects is just one of many. As we continue to look up at the stars and search for answers, we are reminded of how much we still have to learn. Every object we find, every mystery we uncover, brings us closer to understanding the universe we inhabit. And who knows what other incredible discoveries await us in the depths of space. The mystery of interstellar objects is just the beginning, and the journey to unravel it will continue for many years to come. As we explore these interstellar objects, one of the most fascinating aspects is the potential for them to serve as messengers, relics, or artifacts from distant stars. Each object, whether it's Oumuamua, Borisov, or another that may yet be discovered, is a window into the wider galaxy and beyond. Some scientists believe that these objects might even offer a glimpse into the early stages of planetary system formation in other solar systems, as many of these objects are thought to be remnants of a star's formation process, or the breaking apart of a larger planetesimal body. These objects could contain traces of the elements, compounds, and conditions that were present when their parent stars and systems formed. Take Oumuamua, for instance. This object was unusual in ways that we didn't fully expect. Its peculiar, cigar-like shape and rapid acceleration confused scientists. They debated whether it was a comet, an asteroid, or perhaps something completely different. When it was first detected, it was already on its way out of our solar system, making it nearly impossible to study with our limited technology. Some scientists speculated that it might be a fragment from a distant star system, flung into space after a violent collision or some other cataclysmic event. Others theorized that it might be an artificial object, designed by an alien civilization and sent to explore the cosmos, though there was no concrete evidence to support that hypothesis. While Oumuamua was the first interstellar object detected, Borisov came shortly after, and its discovery confirmed that interstellar objects weren't just a fluke. The implications of this discovery were immense. It meant that Oumuamua wasn't an isolated case but part of a much broader phenomenon. While Borisov's trajectory was more predictable and it exhibited the typical characteristics of a comet, its origins outside of our solar system were undeniable. It showed that objects from outside our solar system were not only real but could be detected and studied, even if just briefly. Now, imagine this. What if interstellar objects are a common feature of our galaxy, floating freely between star systems, each carrying within it the history of a distant world? The idea that our solar system might just be one stop among many in a vast cosmic highway is a tantalizing thought. These objects could offer critical insights into other planetary systems that might be radically different from our own. They might even hold clues to the types of life that could exist elsewhere in the universe, life that doesn't resemble anything we know here on Earth. Scientists now believe that the discovery of interstellar objects might be the first step toward exploring interstellar space in ways that were once thought impossible. The detection of these objects could eventually lead to the development of technologies that could allow us to reach them, perhaps sending spacecraft to observe them up close. Imagine sending a probe to the next interstellar visitor, a journey that would take us far beyond the edges of our solar system, into the uncharted regions of space. It's a dream that once seemed purely science fiction but is gradually becoming more plausible as our technology advances. In addition to the mysteries of their origins and what they might reveal about distant star systems, interstellar objects also provide us with a glimpse into the fundamental nature of space itself. The fact that these objects can travel from one solar system to another without losing their identity, without breaking apart or being destroyed by the cosmic forces they encounter, suggests that the vacuum of space is far more resilient than we once thought. The interstellar medium, what's found between the stars, is filled with low-density gas, cosmic dust, and magnetic fields, but it's not empty. These objects must have passed through it, surviving for eons, which speaks to the surprising stability of the void between the stars. Moreover, as we study interstellar objects, we continue to refine our models of space travel and navigation. The more we learn about how these objects move, how they interact with the solar wind, and how they behave under the influence of gravitational forces, the more we learn about the fundamental laws of physics that govern not just our solar system, but the entire galaxy. The discovery of interstellar objects is forcing us to rethink everything we know about celestial mechanics, gravitational forces, and the behavior of matter in space. These objects might not just be passing through our solar system, they could be opening the door to new theories and new ways of thinking about the universe. Then, there's the possibility of discovering something even more extraordinary. What if one day, we find an interstellar object that isn't just a rock, ice, or gas but a piece of something much larger, a broken-off fragment of a star's debris disk or a planet that was destroyed by some cosmic cataclysm? Could we find an object so unique that it challenges everything we know about the life cycles of stars and planetary systems? There's so much we don't yet understand about the evolution of solar systems, and these interstellar visitors could help fill in the blanks, offering crucial evidence of how planets form, how stars die, and how life might emerge in environments that are vastly different from Earth. The search for interstellar objects could also open the door to new discoveries about other galaxies. If we find objects that have traveled from beyond the Milky Way, it would be evidence that intergalactic travel is possible, at least for small objects. Could the matter from other galaxies be drifting through the space between galaxies, carried by forces we don't fully understand yet? Could there be a cosmic exchange of material between different galaxies, much as there's an exchange of material within our galaxy? What if this exchange of material is responsible for the formation of new stars and planets in unexpected places? As exciting as these possibilities are, they also raise new questions about the future of space exploration. If we are able to detect more interstellar objects and study them more closely, what will we learn about the nature of the universe, our place in it, and the potential for life elsewhere? It's possible that the answers to these questions could radically change our understanding of the cosmos, making the search for interstellar objects not just an academic pursuit, but an essential step toward unraveling the mysteries of existence itself. Every discovery about interstellar objects brings us closer to understanding the universe's vast, interconnected nature. The more we learn, the more we realize that the boundaries of what we once thought was possible are continually expanding. What we once considered impossible is now within reach, and what we discover in the coming years could completely reshape our understanding of space, time, and the cosmos. As we continue to explore the mysteries surrounding interstellar objects, it's important to recognize that these celestial visitors also push the boundaries of our technological capabilities. Observing an interstellar object is no small feat. When Oumuamua was first discovered, astronomers had only a narrow window of time to study it. As it passed through our solar system, it quickly accelerated, and its trajectory was such that by the time it had been detected, it was already on its way out, making detailed observation a challenge. This highlighted the necessity for more advanced observational tools and faster detection methods. However, advancements in telescopes and other detection technologies are now allowing us to catch these objects earlier, giving us more time to study them. For instance, the Pan-STARRS telescope, a wide-field survey telescope located in Hawaii, was instrumental in spotting Oumuamua. Similarly, the discovery of Borisov was made possible thanks to the use of powerful sky surveys like the Russian-built 1.5-meter telescope at the Crimean Astrophysical Observatory. These telescopes enable astronomers to search vast expanses of space for objects that might otherwise slip past us unnoticed. Despite these advancements, it remains a significant challenge to track and analyze interstellar objects. Many of these objects are extremely faint, making them difficult to detect in the first place. The sheer vastness of space means that these objects can travel at extraordinary speeds, and they often pass through our solar system in a relatively short period of time. Once they're detected, they're typically too far away to examine in any detail, and by the time we could send a spacecraft to study them up close, the objects would be long gone. But this doesn't mean we're powerless in understanding them. Through careful observation and analysis of the data we collect, astronomers are able to learn a great deal about these objects. By studying their trajectories, their speed, and their interaction with the solar wind, we can infer details about their size, composition, and even their origins. For example, the way that Oumuamua accelerated as it passed through our solar system was one of the key pieces of evidence that suggested it was a comet, even though it didn't display the usual cometary tail. This acceleration was likely caused by outgassing, a process where gas is expelled from the object as it warms up from the heat of the sun, creating a slight push that alters its path. Similarly, the composition of these objects provides valuable information. The first spectroscopic observations of Oumuamua showed that its surface was covered with metals, and the object's reddish hue suggested it was composed of organic molecules, components that are key to life as we know it. This discovery, while not definitive, added fuel to the speculation that Oumuamua could be a relic of a distant, habitable world. Its metallic surface could imply that it was part of a larger, rocky body, possibly a fragment of a planetesimal, or even a planet itself. Another possibility is that these interstellar objects could be older than our solar system itself. If an object like Oumuamua originated from a star system that predated our own, it could carry within it the imprint of an entirely different phase of the universe's history. This opens up the fascinating possibility that some of the materials we see on these objects might have existed long before the formation of the Sun and Earth, giving us a window into the primordial building blocks of the universe. The fact that these objects can travel across vast distances and survive the harsh conditions of interstellar space suggests that they are incredibly resilient. Unlike comets or asteroids within our solar system, which are subject to the gravitational pulls of our planets and the Sun, interstellar objects travel through the cosmic void, encountering very little in the way of matter. This means that, unlike objects within our solar system that can be impacted by collisions or gravitational disturbances, interstellar objects are often relatively unscathed when they enter our solar system. Their long journeys through the void have shaped them into resilient survivors, and each one is essentially a time capsule that has witnessed the unfolding of the universe over unimaginable distances and timescales. The fact that we are beginning to detect and study these objects opens up a new frontier in our understanding of space. These objects are not just random interlopers. They are potentially crucial pieces of the puzzle when it comes to understanding the formation and evolution of planetary systems. They could offer clues about the early stages of planetary system formation in other solar systems, or perhaps even the processes that led to the formation of life elsewhere in the galaxy. As technology advances, the next steps in our exploration of interstellar objects could be groundbreaking. Astronomers and scientists are already brainstorming ways to improve detection methods, develop faster space probes, and send spacecraft to study these objects in person. The dream of one day sending a probe to study an interstellar object up close is not as far-fetched as it once seemed. With advancements in propulsion technology, such as the development of light sails or ion drives, interstellar travel could become a reality. It might take decades or even centuries, but the possibility is no longer a distant fantasy. In the meantime, astronomers are continuing to monitor the skies, keeping an eye out for any more interstellar objects that might pass through our solar system. Every new discovery adds to the growing body of knowledge we have about the cosmos, and every interstellar object offers new mysteries to unravel. Whether we are studying their origins, their composition, or the strange behavior they exhibit as they interact with the solar wind, these objects are pushing the boundaries of what we know about space. What makes interstellar objects even more intriguing is the possibility that they could be part of a larger cosmic phenomenon that we have yet to fully understand. Could these objects be the result of some as yet undiscovered process in the formation of stars and planets? Are they sentient or the remnants of some lost civilization, their remnants scattered across the universe after their creators vanished? While the scientific community generally remains skeptical of the idea of alien spacecraft, the possibility that these objects may harbor clues about extraterrestrial life or advanced civilizations can't be entirely dismissed. As we continue to study them, we may find evidence that pushes us to reconsider what we know about the universe and our place in it. One of the most exciting aspects of the discovery of interstellar objects is the potential for future breakthroughs in space exploration. These objects could open new pathways for us to explore distant regions of the universe, perhaps even providing us with a roadmap to other star systems. If we can unlock the secrets of these objects, we might be able to extend our reach beyond our own solar system, exploring new worlds and uncovering mysteries that have eluded us for centuries. As we look to the future, the study of interstellar objects is not just about understanding what we see in the sky today. It's about understanding the universe on a much deeper level, how stars form, how planets are created, and how life might emerge in the most unlikely places. It's about understanding the past, present, and future of our universe. And it all starts with these mysterious visitors from beyond our solar system. The mysteries surrounding interstellar objects are not just scientific curiosities. They are gateways to the broader questions of space exploration. Understanding their origins, behavior, and composition will require more than just observation. It will require new paradigms of thinking, more sophisticated models of how the universe functions, and an expansion of our methods of space exploration. What makes the study of objects like Oumuamua and Borisov even more compelling is that they are not just anomalous visitors. They represent a new class of objects that challenge our existing framework for understanding the cosmos. The study of interstellar objects is like a cosmic detective story, where each clue, no matter how small, could radically alter our understanding of space. But we are not just observers in this mystery. The technology we develop to better study these objects will have profound implications for how we conduct space exploration moving forward. New observational techniques, such as more sensitive infrared telescopes or innovative radio wave detection methods, could allow us to study these objects even after they've passed through our solar system, helping us gather data over much longer periods of time. Take, for instance, the efforts underway to launch missions to explore other star systems, like the proposed breakthrough Starshot initiative. While it might be decades or even centuries before we can send probes to explore other star systems, the study of interstellar objects provides us with a kind of proof of concept. These objects are like mini ambassadors, carrying with them crucial information about the environments of other star systems. They might even offer hints about whether life, or the precursors to life, exists beyond our solar system. The hope is that with each new interstellar visitor, we are one step closer to answering the age-old question, are we alone? Another profound aspect of studying interstellar objects is their role in the search for extraterrestrial life. While many astronomers remain cautious about jumping to conclusions about alien life or intelligence, the mere fact that interstellar objects exist could suggest that there may be more to the universe than we currently understand. Some speculate that these objects may be relics of far-off civilizations, sent on a journey across the cosmos for reasons we may never fully comprehend. Of course, this is an area ripe for speculation, and any such conclusions would be highly speculative at this stage. But it is a reminder of how much we still have to learn about the universe. Interestingly, some have even proposed that Oumuamua could be a probe or signal of some kind, designed to study our solar system. While the majority of the scientific community rejects this hypothesis, the idea remains an intriguing thought experiment. In our search for extraterrestrial life, we often think in terms of sending signals or spacecraft to other worlds. But what if the reverse were true? What if we were the ones being studied? This concept opens up a rich field of debate, especially when coupled with the strange and unexplained features of objects like Oumuamua. It's important to note, however, that the extraordinary nature of interstellar objects doesn't mean that every unexplained phenomenon we observe can be attributed to alien technology. As much as we are naturally drawn to extraordinary explanations, the scientific method encourages us to consider more mundane possibilities first. In the case of Oumuamua, the debate over its shape, acceleration, and unusual behavior may have sparked wild theories, but it's also spurred a closer look at the physics of how objects move through space and how they can interact with solar radiation. The answer to these questions could unlock entirely new understanding of the forces that shape the universe. To this day, many astronomers are still debating the nature of Oumuamua's strange acceleration. Some have suggested that it was influenced by the pressure of sunlight, a phenomenon known as the Yarkovsky effect, which can cause objects in space to change their trajectory by absorbing sunlight and re-emitting it as heat. Others believe that outgassing, similar to what happens with comets, could have been responsible for the acceleration, but without the typical visible tail. While these ideas are all scientifically grounded, none of them fully explains why Oumuamua behaved in such an unusual way. The absence of a tail and the object's high speed have made its classification difficult, and researchers are still examining all possibilities. Meanwhile, Oumuamua's peculiarities also raised more philosophical questions about how we approach the unknown. Could this be an indication of something we simply don't have the technology or understanding to explain yet? Is our current framework of astronomy and physics limiting us in ways we cannot yet perceive? The fact that we are still in the dark about key aspects of Oumuamua's nature reveals just how much we still have to learn. Our capacity to understand the universe is still in its infancy, and we are just beginning to scratch the surface of what's out there. When Borisov appeared in 2019, it provided a new opportunity to study an interstellar object with more advanced equipment. Unlike Oumuamua, which had a more elongated shape, Borisov was much more like a typical comet, with a tail and a visible gas cloud. Its behavior offered astronomers a second chance to study the dynamics of interstellar objects, and for many, it provided crucial insights that could shed light on Oumuamua's mystery. However, even though both objects are interstellar, the stark differences in their characteristics highlight the wide variety of objects that may exist beyond our solar system. They represent just a fraction of the possibilities, and the universe is likely filled with countless other interstellar objects waiting to be discovered. Even with these advances, there are still major questions that remain. Are interstellar objects common or rare? We've only observed a handful, but there are undoubtedly many more out there, drifting between the stars, possibly passing through our solar system without being detected. Some scientists suspect that there could be an entire population of interstellar objects out there, yet we lack the tools to find them. Newer and more sensitive telescopes, as well as improved data analysis techniques, are being developed to help us uncover more of these objects, but it's possible that we may never be able to detect them all. The notion of a hidden, vast population of interstellar objects is a tantalizing thought. After all, space is unimaginably vast, and our current observational reach is limited to only a tiny fraction of the sky. If the universe is truly teeming with these objects, then the discovery of just a few could be the tip of the iceberg. In the coming decades, as technology improves and our understanding of space evolves, we may find that interstellar objects are far more common than we could have ever imagined. Looking forward, the exploration of interstellar objects may hold the key to unlocking some of the greatest mysteries of space. We may not fully understand their origins, but each discovery brings us one step closer to solving the puzzle. As more objects are detected and analyzed, we can expect to learn more about the formation of stars and planets, the nature of life beyond Earth, and even the distant history of our own solar system. But perhaps the most exciting possibility is that these interstellar travelers could one day lead us to the discovery of extraterrestrial life, or at the very least, help us better understand how life might arise in other parts of the universe. Whether these objects are remnants of ancient planetary systems, survivors of cosmic catastrophes, or even evidence of alien civilizations, they are providing us with clues that could fundamentally reshape our understanding of the cosmos. The study of interstellar objects reminds us that there is still so much left to discover. As we continue to push the boundaries of space exploration, we are reminded that the universe is full of surprises, many of which are just waiting to be uncovered. The mystery of Oumuamua, Borisov, and other interstellar objects is far from over. In fact, it's just beginning. As we continue our exploration of interstellar objects, we must acknowledge the enormous potential these objects hold in transforming our scientific perspective. They are not merely fleeting visitors from distant parts of the cosmos. They are signposts, messages from other star systems, carrying with them data that could help us unlock mysteries about the birth of stars, the formation of planets, and possibly even the conditions that foster life beyond Earth. One of the most exciting aspects of these interstellar visitors is their role in expanding our understanding of stellar and planetary systems. As we study objects like Oumuamua and Borisov, we gain insights into the environments of other star systems. These objects are relics of systems that may be vastly different from ours, perhaps older, colder, or more exotic. They could provide evidence of planetary systems that formed under entirely different conditions than our own, challenging everything we think we know about the processes that lead to the creation of planets and moons. Furthermore, the physical properties of these objects may offer tantalizing clues about the early stages of planetary formation. While the objects themselves may be relatively small, their composition could offer insights into the building blocks of stars and planets. For example, Oumuamua was detected to have an unusual reddish hue, indicating the possibility of a metal-rich composition. If this is true, it could suggest that the object's home star system had a different chemical makeup than our own. Borisov, on the other hand, resembled more familiar comets in our solar system, with its icy nucleus and gaseous tail, pointing toward a shared cosmic heritage but perhaps influenced by different interstellar conditions. These differences are important because they suggest that planetary systems, including our own, may not be as unique as we once thought. There is the possibility that planetary systems can form in a wide variety of environments, which means that the potential for life, whether microbial or intelligent, could exist in far more places than we can currently imagine. The key to understanding this lies in the study of interstellar objects, which can serve as cosmic messengers, telling us about the diverse environments in which life could thrive. The idea that we might someday encounter evidence of life beyond Earth in the form of an interstellar object is an exciting thought. Of course, this is still speculative, but it underscores the significance of studying these objects. Even the most unusual of them could offer profound insights into the question of whether we are alone in the universe. While the majority of astronomers remain cautious in their interpretations, it's important to keep an open mind. Just as we once thought the Earth was the center of the universe, we could find that the true scope of life in the universe is far more vast and complex than we can yet comprehend. The discovery of interstellar objects has also led to an unexpected shift in the way we think about space exploration. Traditionally, our space missions have focused on objects within our solar system, planets, moons, asteroids, and comets that are part of our cosmic neighborhood. But the sudden appearance of interstellar visitors has prompted scientists to reconsider the scope of their ambitions. Could interstellar exploration be the next frontier in space travel? The fact that these objects are coming from other star systems, systems that may be billions of years old, raises the possibility that we could someday travel to these distant regions ourselves. Though such missions would take centuries to complete, just knowing that it might one day be possible is an exciting prospect. To make such missions a reality, humanity would need to develop new forms of space travel. Proposals like Breakthrough Starshot, which aims to send tiny, lightweight probes to the Alpha Centauri system at speeds approaching 20% of the speed of light, are a step in that direction. These probes would be equipped with high-powered lasers that would propel them toward their destinations at unprecedented speeds. While these concepts are still in the early stages of development, they highlight the growing recognition of the importance of interstellar exploration. Interstellar objects are also changing the way we think about our solar system. For centuries, our solar system was viewed as a relatively self-contained entity, with clear boundaries defined by the outer reaches of the Kuiper Belt and the Oort cloud. However, the discovery of interstellar objects has challenged this view. Rather than being isolated in space, our solar system is part of a dynamic and interconnected galaxy. Objects from other star systems can pass through our cosmic neighborhood, and in the future, our spacecraft could venture beyond the confines of our solar system, exploring the broader galaxy. In this sense, interstellar objects are reshaping our understanding of what it means to be part of a larger, interconnected universe. As we continue to observe and study interstellar objects, one question that frequently arises is whether these objects are part of a larger, undetected population of interstellar travelers. The fact that we have only detected a handful of such objects suggests that there may be many more out there, passing through our solar system unnoticed. It's possible that, just as the detection of asteroids and comets was once a rare occurrence, we may eventually detect a steady stream of interstellar objects, each providing us with more data to understand the processes that govern the universe. In addition to the scientific discoveries that interstellar objects provide, they also bring with them the potential for philosophical and existential reflection. If interstellar objects are remnants of distant star systems, then their very presence suggests that the universe is far older and more complex than we can fully comprehend. Every object that passes through our solar system is a tiny piece of a much larger puzzle, and studying these objects helps us piece together the story of the cosmos. As we continue to probe the mysteries of the universe, we are not just learning about the past, we are also preparing for the future, laying the groundwork for future generations to explore the farthest reaches of space. Moreover, the discovery of interstellar objects forces us to rethink our place in the universe. For much of human history, we have viewed Earth as the center of the universe, with the sun and the stars serving as distant background players in a cosmic drama. But as we learn more about objects that travel between the stars, we are confronted with the reality that the universe is a vast, interconnected web, where objects can move freely between star systems, undeterred by the boundaries of individual solar systems. This realization underscores how small and interconnected we are in the grand scheme of the cosmos. One final area of exploration that remains largely unexplored is the potential role of interstellar objects in the future of space colonization. If humanity ever reaches the point where interstellar travel becomes a reality, objects like Oumuamua and Borisov could provide critical information about the best destinations for future colonies. Could these objects point us to other star systems with habitable planets? If so, we would need to know not only how to reach these systems, but also what kind of environments we would encounter when we arrive. Interstellar objects could hold the key to answering these questions, offering us a glimpse of the conditions on exoplanets that might support life or provide the resources needed to establish human colonies. As the search for more interstellar objects continues, the broader implications of their discovery will shape the future of space exploration, scientific discovery, and even our understanding of our place in the universe. These objects offer us a window into a vast, unexplored frontier, one that is brimming with potential, mystery, and wonder. As we continue exploring the mysteries surrounding interstellar objects, it's important to consider the various methods scientists are employing to study them. The detection and analysis of interstellar objects represent a significant leap in both observational technology and our understanding of the universe. Historically, astronomers have relied on optical telescopes and radio observatories to detect and study objects within our solar system. However, the arrival of interstellar objects has pushed the boundaries of what's possible. Now, more advanced tools are required, and scientists are getting creative in how they study these objects. One of the key tools in detecting interstellar objects is the use of observatories equipped with wide-field cameras that scan the night sky for faint objects moving at high speeds. When Oumuamua was first detected in 2017, it was spotted by the Pan-STARRS 1 telescope in Hawaii. This telescope, along with others like it, is constantly scanning the sky for any unusual objects, including asteroids, comets, and now interstellar visitors. When these objects are detected, astronomers use a combination of optical and infrared telescopes to observe them in greater detail, tracking their movements and analyzing their composition. But even with such advanced equipment, capturing the full picture of an interstellar object can be challenging. These objects tend to move quickly through our solar system, and because they're often faint, they can be difficult to spot early enough to conduct thorough studies. For instance, Oumuamua, which was only detected after it had already passed closest to the Sun, had already begun its journey out of our solar system by the time it was fully analyzed. This limitation has prompted a push for more dedicated observatories and the development of new techniques for catching these objects earlier. If we are to gain a deeper understanding of these mysterious travelers, it will be crucial to enhance our detection capabilities. The importance of detecting interstellar objects early cannot be overstated. The earlier an object is detected, the longer scientists have to observe it, and the more data they can gather. This is especially important for studying the trajectories of these objects. Understanding where they came from, their speed, and their path through the galaxy can provide crucial insights into the origins of these objects and the regions of space they inhabit. For example, the peculiar shape and acceleration of Oumuamua raised many questions, with some even suggesting that it could have been an artificial object, though this theory remains speculative. The more we can learn about the characteristics of interstellar objects, the more we can refine our models of interstellar space and gain a clearer picture of the universe at large. One aspect that remains particularly intriguing about objects like Oumuamua and Borisov is their mysterious origins. While scientists have been able to track their movements and determine their velocities, their exact origins are still uncertain. In fact, both objects have prompted more questions than answers. Oumuamua, for instance, was not only the first interstellar object to be detected but also one of the most unusual. It exhibited strange, unexplained acceleration as it passed through our solar system, which scientists have struggled to explain. Some have speculated that this acceleration could have been caused by the pressure of sunlight pushing against the object, causing it to change speed, while others have suggested that the object could have been a fragment of a larger body, possibly expelled from its original star system by some kind of violent cosmic event. Borisov, on the other hand, presented a more familiar appearance as a comet, complete with a dust and gas tail. However, its interstellar nature added a layer of mystery to what would otherwise have been a relatively standard discovery. The fact that it was also the second interstellar object ever detected points to a pattern that suggests there are many more objects out there, waiting to be discovered. This opens up new questions. Are these objects common in the galaxy, or are they rare? Do they follow predictable paths, or are their trajectories completely random? The answers to these questions could significantly shape our understanding of the dynamics of interstellar space. As more objects are discovered, scientists are also grappling with the question of how to distinguish between objects that originate from outside our solar system and those that come from within. While Oumuamua and Borisov were easily identified as interstellar objects due to their high velocities and unusual trajectories, not every object that passes through our solar system is an obvious candidate. With time, it's expected that astronomers will develop more refined techniques to identify interstellar visitors, allowing us to better understand the nature of these objects and the processes that bring them into our solar system. The mystery of interstellar objects also raises important questions about the potential for life beyond Earth. While it's unlikely that these objects themselves harbor life, they may contain the building blocks of life, such as organic molecules, that could have been formed in other star systems. In this sense, interstellar objects could serve as cosmic messengers, carrying with them information about the chemical and physical conditions that prevail in other parts of the galaxy. The presence of organic compounds on objects like Oumuamua and Borisov would be a game-changer in the search for extraterrestrial life, suggesting that the conditions necessary for life could exist elsewhere in the universe. If these objects do indeed contain the basic ingredients for life, it's possible that they could be part of a larger phenomenon that scientists have speculated about for years: Panspermia. This is the idea that life, or at least its precursors, could travel across space, from one star system to another, carried on comets, asteroids, or even interstellar dust. The theory posits that life could have originated elsewhere in the galaxy and then been transferred to Earth on an interstellar object, seeding our planet with the building blocks of life. While this remains a speculative idea, the discovery of complex organic molecules on interstellar objects would lend support to this theory, adding a new layer of intrigue to our understanding of life's origins. Moreover, the mystery of these interstellar objects has the potential to fuel public imagination and inspire future generations of scientists, engineers, and explorers. As humanity moves toward the goal of interstellar exploration, the discoveries made through studying objects like Oumuamua and Borisov could provide critical insights that help shape the technologies and strategies required to travel beyond our solar system. The study of these objects is not just about understanding the present. It's also about preparing for a future where space travel and exploration are part of our everyday reality. In the future, it is conceivable that interstellar missions could be launched to study these objects in greater detail. If the technology advances enough, we may even be able to send probes to intercept and analyze objects like Oumuamua or Borisov while they're still in our solar system. Such missions would be incredibly challenging, requiring new spacecraft designs, propulsion technologies, and instruments capable of detecting and analyzing interstellar material in real time. However, as we continue to advance our capabilities in space exploration, the prospect of studying interstellar objects up close becomes more and more feasible. The mystery of interstellar objects is far from being solved, and as scientists continue to investigate objects like Oumuamua and Borisov, new questions will inevitably arise. Each interstellar object is a reminder that our understanding of the universe is still incomplete, and that there is so much more to discover beyond the familiar boundaries of our solar system. As we continue to refine our detection methods, study the chemical compositions of these objects, and explore their potential connections to life beyond Earth, the mysteries surrounding them will unfold, offering us a deeper, more nuanced view of the cosmos and our place within it. These objects, though fleeting, are cosmic messengers that connect us to the vast and uncharted territories of the universe, and their study holds the promise of unlocking secrets that could change everything we know about the origins of the universe, life, and the future of space exploration. As we continue our exploration of the mysteries surrounding interstellar objects, it's important to delve into the implications of these objects for our understanding of the universe. The discovery of interstellar objects like Oumuamua and Borisov raises several profound questions, many of which could reshape our entire worldview. These objects are not just curiosities, they are windows into a vast and largely unexplored part of the universe, offering us a glimpse into the nature of interstellar space and the forces that govern it. One of the most compelling questions that scientists are grappling with is whether interstellar objects could provide clues about the formation of planetary systems beyond our own. These objects, as remnants of other star systems, could contain information about the early stages of planetary formation, much like how the asteroid belt in our solar system offers a snapshot of the early solar system. By analyzing the chemical composition, size, and structure of interstellar objects, we can learn about the conditions that exist in other star systems and how they might differ from or resemble our own. This could provide valuable insights into the process of planetary system formation, offering a broader perspective on how our own solar system came to be. Additionally, the study of interstellar objects could help answer fundamental questions about the behavior of matter and energy in interstellar space. We know that space is not completely empty. It contains dust, gas, magnetic fields, and cosmic radiation, all of which influence the movement and properties of objects passing through it. By studying the trajectory, velocity, and behavior of interstellar objects, we can gain a better understanding of the conditions in the vast spaces between stars. For instance, the acceleration observed in Oumuamua has sparked intense debate among scientists, with some proposing that it could be caused by the push of solar radiation, while others speculate that it might be a sign of some other exotic phenomenon. Each of these possibilities opens up new avenues of exploration, potentially revealing previously unknown aspects of the physics that govern the cosmos. Another fascinating aspect of interstellar objects is their potential to challenge our understanding of the solar system itself. The fact that objects from other star systems are capable of entering our own solar system suggests that the boundaries of the solar system are not as well defined as we once thought. For centuries, we have considered the solar system to be a relatively closed system, with the sun's gravitational pull acting as a shield, preventing objects from entering from outside. However, the detection of interstellar objects calls into question the rigidity of this boundary. In a sense, these objects act as visitors from afar, temporarily passing through our solar system before continuing on their journey through the galaxy. This raises the intriguing possibility that our solar system might be much more connected to the rest of the galaxy than we ever realized, with objects from distant stars constantly passing through, even if we don't always detect them. As scientists continue to gather more data on interstellar objects, it's also worth considering the broader implications of their discovery. The existence of these objects challenges our current models of the solar system and the larger structure of the galaxy. For example, the fact that Oumuamua and Borisov were able to travel from other star systems without any obvious signs of being altered by the sun's gravity or radiation suggests that there may be forces at play that we don't fully understand. The mysteries surrounding their trajectories and behavior point to gaps in our understanding of how objects move through space and how they interact with their environments. As we seek to fill in these gaps, we may uncover new principles of physics that could revolutionize our understanding of the cosmos. Perhaps one of the most exciting aspects of studying interstellar objects is the potential for new discoveries that could fundamentally alter our conception of the universe. These objects may hold the key to answering some of the most profound questions about the origins of life, the structure of the galaxy, and the nature of space itself. For instance, as we mentioned earlier, interstellar objects may contain organic molecules or other materials that are key to the formation of life. If these objects can be shown to harbor the building blocks of life, it could provide evidence for the theory of Panspermia, suggesting that life on Earth may not have originated here at all, but instead might have been seeded by interstellar objects traveling through space. This would be a groundbreaking discovery with profound implications for our understanding of life, not just on Earth but across the universe. In addition to the biological implications, studying interstellar objects could also help us refine our search for extraterrestrial intelligence. By analyzing the properties of these objects, we can learn more about the kinds of environments that might support life elsewhere in the galaxy. For example, if we find that certain types of interstellar objects contain specific organic compounds or minerals that are associated with life, it could help narrow down the search for habitable planets in other star systems. Furthermore, the possibility that some of these objects could be artificial in origin, as some have speculated about Oumuamua, opens up the intriguing prospect that these objects could be evidence of extraterrestrial civilizations. While this remains highly speculative, the very idea that an interstellar object could be a message from another civilization would be one of the most profound discoveries in the history of humanity. The search for interstellar objects is not just an academic exercise. It has practical implications for the future of space exploration as well. The study of these objects could help us develop better strategies for exploring other star systems. For instance, if we can learn more about the composition and behavior of interstellar objects, we can better prepare for future missions to the stars. This might include developing spacecraft capable of traveling to interstellar destinations or creating technology that can capture and study objects as they pass through our solar system. The technologies developed for studying interstellar objects could also have applications in other areas of space exploration, from asteroid mining to the study of comets and the search for habitable exoplanets. As we look to the future, the study of interstellar objects is sure to play an increasingly important role in our understanding of the universe. In the coming decades, new observatories and telescopes will be built that will improve our ability to detect and study these objects. With the development of more advanced technologies, it may even be possible to send probes to intercept interstellar objects, allowing us to study them up close and gather more detailed data than ever before. These missions would be incredibly challenging, but the potential rewards are immense, offering us the chance to unlock some of the greatest mysteries of the cosmos. As we continue to explore the mystery of interstellar objects, it's clear that we are on the cusp of a new era of discovery. Each new object that passes through our solar system adds another piece to the puzzle of our understanding of the universe. The more we learn about these objects, the more we realize that our place in the cosmos is far more dynamic and interconnected than we ever imagined. Whether these objects are natural or artificial, whether they contain the seeds of life or simply offer a snapshot of a distant star system, their study holds the promise of revealing new truths about the nature of the universe and our place within it. As we continue to look to the stars, the mystery of interstellar objects will undoubtedly lead us to new frontiers of knowledge, helping to shape the future of space exploration and our understanding of the universe. As we continue to unravel the mysteries of interstellar objects, it's important to take a deeper look at the technological advancements that have made these discoveries possible. In the past, our ability to detect objects like Oumuamua and Borisov was limited by the tools at our disposal, but today's rapidly advancing space exploration technologies are opening new doors to our understanding of these cosmic visitors. One of the key developments in this area has been the improvement of astronomical observatories and telescopes. For instance, the Pan-STARRS Panoramic Survey Telescope and Rapid Response System Observatory in Hawaii played a pivotal role in the discovery of Oumuamua, catching the object as it passed through our solar system. Pan-STARRS uses advanced imaging technology to scan the sky for potential threats like asteroids, as well as other interesting objects that could provide new insights into space. As more observatories like Pan-STARRS come online, our ability to detect and track interstellar objects will only improve, leading to more discoveries and deeper analysis. In addition to ground-based telescopes, space-based observatories such as the Hubble Space Telescope and the upcoming James Webb Space Telescope, JWST, are further expanding our reach. Hubble has been instrumental in studying objects within our own solar system, but JWST is expected to revolutionize our understanding of distant objects and phenomena, including interstellar visitors. With its unparalleled ability to observe in infrared wavelengths, JWST will allow us to study the composition, structure, and motion of objects like Oumuamua and Borisov in much greater detail than ever before. As JWST begins its mission, we can expect to uncover new data about the physical characteristics of these objects, helping us to answer some of the most fundamental questions about their origins and behavior. Another important aspect of the technological leap forward is the rise of artificial intelligence, AI, and machine learning in the field of astronomy. These technologies are being used to sift through vast amounts of data collected by telescopes and observatories, helping astronomers identify objects that would otherwise go unnoticed. AI algorithms can analyze images and detect patterns that human eyes might miss, allowing us to spot interstellar objects as they approach our solar system and track their movement in real time. This technology is already helping scientists identify and predict the paths of asteroids, comets, and even potentially hazardous objects, and it holds great promise for improving our ability to spot and study interstellar objects before they pass by. The advent of AI also opens up new possibilities for analyzing the data collected from interstellar objects. For example, AI can be used to analyze the chemical composition of these objects, helping to identify the presence of organic compounds or other materials that could reveal important information about the conditions in other star systems. With the ability to process large datasets quickly, AI is helping astronomers make faster breakthroughs, accelerating our understanding of interstellar objects and the forces that shape them. While technological advancements are crucial, it's important to remember that interstellar objects also present a unique set of challenges for scientists. For one, these objects are moving at incredible speeds. Oumuamua, for example, was traveling at speeds of up to 196,000 miles per hour, 315,000 kilometers per hour, as it passed through our solar system. This high velocity makes it incredibly difficult to track objects like Oumuamua, which doesn't remain in the solar system long enough for detailed observation. In fact, by the time astronomers realized that Oumuamua was an interstellar object, it was already on its way out of our solar system, making it even more challenging to gather data on its composition or origin. This raises a critical point. How can we study these objects if they don't linger in our solar system long enough to gather the necessary data? The answer lies in developing faster, more advanced spacecraft and observational techniques. Scientists are currently working on plans to send probes to intercept interstellar objects as they pass through our solar system. These missions would involve spacecraft capable of traveling at speeds fast enough to reach the objects before they leave the solar system, allowing for a close-up study of their composition and behavior. These missions would be incredibly difficult, but the potential rewards in terms of scientific discovery are immense. Imagine being able to land a probe on an interstellar object and send back data about its structure, chemical makeup, and perhaps even signs of past or present life. Such missions could completely change our understanding of the cosmos and our place within it. The idea of exploring interstellar objects is not as far-fetched as it might seem. In fact, the concept of sending probes to distant objects has been discussed for years, and recent advancements in propulsion technology have brought this dream closer to reality. For example, the development of ion propulsion systems, which use electrically charged particles to propel a spacecraft, has made it possible to achieve higher speeds and longer travel times than traditional chemical rockets. This technology could one day enable missions to reach the farthest reaches of our solar system and even venture into interstellar space. The idea of interstellar exploration is no longer confined to the realm of science fiction. It's becoming a real possibility. One of the most intriguing proposals for studying interstellar objects comes from the breakthrough Starshot initiative. This ambitious project aims to develop small, lightweight spacecraft that could travel at a significant fraction of the speed of light, enabling them to reach distant star systems in just a few decades. While breakthrough Starshot is focused on sending probes to nearby stars, the technology developed for this initiative could eventually be used to explore interstellar objects as well. Imagine sending a fleet of tiny spacecraft, each equipped with advanced sensors and cameras, to chase down interstellar objects and study them as they zoom through our solar system. This type of mission would provide a level of detail and precision that we've never been able to achieve before. Even if we don't send probes to these objects in the near future, we can still learn a great deal by continuing to observe them with the tools available to us. As technology advances, we will become better at tracking interstellar objects, identifying their origins, and understanding the forces that shape their trajectories. In the meantime, we can focus on gathering as much data as possible from each object that crosses our path. Each new discovery adds another piece to the puzzle, and with each piece, we come closer to answering the most profound questions about the nature of the universe. It's clear that these cosmic visitors hold the potential to reshape our understanding of the universe in ways we can't yet fully imagine. From their origins in distant star systems to the forces that govern their movement, interstellar objects provide us with a unique opportunity to study the broader cosmos beyond our solar system. These objects are not just passing curiosities. They are messengers from the far reaches of space, offering us glimpses of the forces and processes that shape the universe. In the years to come, as technology continues to improve and our understanding of these objects deepens, we will likely unlock even more mysteries about the nature of the cosmos. The study of interstellar objects is still in its infancy, but with each new discovery, we move one step closer to unraveling the secrets of the universe. Whether they are harbingers of life, remnants of distant star systems, or simply strange, unexplained phenomena, interstellar objects are sure to remain a source of fascination and discovery for generations to come. As we push further into the realm of interstellar objects, the implications of their existence continue to stretch the boundaries of our knowledge. Imagine, for a moment, that every interstellar object is not merely a fleeting anomaly but a piece of a cosmic puzzle, offering insights into the wider structure of the universe. The fact that such objects can travel across vast distances, surviving the harshness of interstellar space, only to find their way into our solar system, sparks endless curiosity. The mystery of how they form, why they travel the way they do, and what they can teach us about the universe's origins keeps us on the edge of discovery. Let's take a deeper dive into the question that has captivated scientists for years. What can we learn from the strange and mysterious behavior of interstellar objects like Oumuamua and Borisov? Their arrival in our solar system is just the beginning of the story, and as we peel back the layers of data, we uncover more complex and intriguing details. There are several key aspects of these objects that remain unexplained, and each one presents a unique opportunity to push the limits of what we know about space. First, let's revisit the behavior of Oumuamua, the object that started the fascination with interstellar visitors. Its strange, elongated shape, combined with its rapid speed and unusual trajectory, raised immediate questions. Astronomers and physicists were baffled when they first observed it in 2017. The object didn't behave like anything we had encountered before in our solar system. It didn't fit the pattern of typical asteroids or comets that usually pass through our solar system. Instead, its movement seemed to defy the gravitational pull of the Sun in a way that suggested it was being affected by some unknown force. One of the most fascinating aspects of Oumuamua's journey was its acceleration as it moved away from the Sun. Unlike typical objects that slow down or follow a predictable path based on gravitational forces, Oumuamua sped up without any clear explanation. Some scientists initially speculated that it could be a comet, with gas or dust pushing it forward, but there was no visible tail. Others suggested that its strange motion could be due to the pressure exerted on it by solar radiation, essentially, sunlight pushing on the object like a solar sail. However, this didn't account for all the observed data, and the object's peculiar characteristics only deepened the mystery. To make matters even more perplexing, some researchers proposed that Oumuamua could be artificial in nature, perhaps a probe sent by an advanced civilization. This outlandish theory generated much debate, with proponents suggesting that the object's rapid motion and unusual shape could indicate it was a technological artifact rather than a natural object. While the idea remains controversial and highly speculative, it underscores the degree to which Oumuamua captured the imagination of the scientific community and the public alike. So, what could Oumuamua actually be? The truth is that, even today, we don't have a clear answer. Some scientists now believe that it could be a fragment of a much larger object that was ejected from its home star system. Others suggest that it might be a space iceberg, an icy body from another system that survived the journey across interstellar space. The shape of Oumuamua could even be a result of the way it fragmented or broke apart during its long travel. Whatever its origin, Oumuamua's arrival in our solar system marked the beginning of a new era in space exploration, where the study of interstellar objects will likely become a regular part of our cosmic investigations. Then there's Borisov, the second interstellar object to be observed, arriving just 2 years after Oumuamua. Unlike Oumuamua, Borisov exhibited the traits of a typical comet, with a visible tail that indicated it was composed of ice and dust. It was discovered in 2019 by amateur astronomer Gennady Borisov, and it quickly became the subject of intense study. While its behavior was more predictable than Oumuamua's, its origin as an interstellar visitor was still mind-boggling. Borisov was not from our solar system, but from an entirely different part of the Milky Way galaxy, having traveled billions of miles to reach us. What makes Borisov so interesting is that it provides a valuable comparison to Oumuamua. While Oumuamua's behavior sparked wild theories about its nature, Borisov's more traditional characteristics have helped scientists refine their understanding of how interstellar objects behave. By studying Borisov's composition and movement, astronomers gain new insights into the dynamics of interstellar comets and how they interact with the solar wind and other forces. This kind of data is crucial in helping scientists better predict the behavior of future interstellar objects. There's another crucial aspect of these interstellar visitors that is not often discussed: what we can learn about the other star systems they come from. If objects like Oumuamua and Borisov are representative of the materials found in their home systems, then studying them could provide us with a snapshot of the conditions that prevail in other parts of the galaxy. Their chemical composition, structure, and behavior can offer clues about the types of stars, planets, and potential life forms that might exist elsewhere. It's as if these objects are cosmic messengers, bringing us news from distant worlds we can't yet reach. Even more intriguing is the possibility that these objects could be a sign of a much larger phenomenon. Imagine that Oumuamua and Borisov are part of a larger family of interstellar visitors, traveling through our solar system in regular intervals. If we could identify and track more of these objects, we might be able to map out patterns of interstellar travel that would give us a better understanding of how material moves between star systems. This could have profound implications for our understanding of how galaxies evolve, how life might spread throughout the universe, and how the building blocks of planets and stars are exchanged across vast distances. This idea of interstellar material exchange opens up a new field of exploration, the potential for life beyond our solar system. While the search for extraterrestrial life has traditionally focused on finding planets within the habitable zone of nearby stars, interstellar objects like Oumuamua and Borisov could offer a more direct way to investigate the question of life beyond Earth. If these objects contain the necessary ingredients for life, or if they carry with them signs of life from their home systems, it could suggest that life in the universe might be more widespread than we previously thought. And yet, as we continue to study these objects and develop new technologies for tracking and analyzing them, one question remains: are we truly prepared for the future of interstellar exploration? The mystery of interstellar objects has only just begun, and as more of these visitors make their way through our solar system, we will undoubtedly learn even more about the forces that shape our universe. With each new discovery, we inch closer to answering some of the most fundamental questions about the origins of the cosmos and the possibility of life beyond Earth. So, as we look to the future, one thing is clear: the study of interstellar objects like Oumuamua and Borisov is only the beginning of what promises to be a thrilling journey into the unknown. With every new interstellar visitor that arrives, we open another chapter in the story of the universe, one that holds the potential to change everything we know about space, time, and the very nature of existence itself. The possibilities that interstellar objects present go far beyond what we might initially expect. Not only do they raise fundamental questions about the nature of space and the universe, but they also challenge the way we think about our place in the cosmos. These mysterious travelers, seemingly from distant parts of the galaxy, remind us just how vast and interconnected everything is. We may be just a small part of a much larger cosmic narrative that stretches far beyond the borders of our solar system. But what makes these interstellar objects so unique, and why do they capture our imaginations in such a profound way? One key factor is the notion of interstellar space itself. The void between stars is often perceived as an empty, lifeless region, where particles and objects are few and far between. Yet the existence of interstellar objects challenges this view. These objects, which have journeyed across vast stretches of space, demonstrate that there is far more happening in these regions than we once thought. It's not a static, empty space at all. Instead, it's a dynamic environment, where objects can be launched, ejected, and even collide with one another, creating pathways for objects to travel great distances. This idea of objects moving through interstellar space opens up the fascinating possibility that there may be other unknown objects out there, traveling from other star systems, yet to be discovered. We have only scratched the surface of understanding how frequent these interstellar visitors might be. If the arrival of Oumuamua and Borisov is anything to go by, we could be on the verge of discovering many more such objects in the coming years. And with the advancement of technology, especially the development of more sensitive telescopes and observation methods, our ability to detect these objects will only improve, making it increasingly likely that we will find even more of them. But the implications of these discoveries are not just limited to scientific curiosity. They carry with them profound philosophical and existential questions about the nature of our universe and our place within it. The discovery of interstellar objects implies that we are not isolated in our corner of the galaxy. These objects are a testament to the interconnectedness of the universe, suggesting that the material that makes up stars, planets, and even the building blocks of life is constantly moving and interacting across vast distances. This interconnectedness challenges our traditional view of space as a vast, empty void, and instead paints a picture of a universe teeming with activity, constantly in motion, and forever shifting. Moreover, the very existence of these objects raises the question, could there be others like Oumuamua and Borisov, carrying with them valuable information about the conditions and potential for life in other parts of the galaxy? As we explore further, the possibility that some of these objects could harbor essential elements for life, chemicals, compounds, or even microbes, becomes an exciting area of investigation. It may sound far-fetched, but the idea that life could travel between star systems, hitching a ride on these objects, is not as outlandish as it may seem. In fact, Panspermia, the theory that life could spread across the cosmos through objects like asteroids and comets, has been a topic of scientific speculation for quite some time. The arrival of interstellar objects only adds weight to this theory, providing tangible evidence that material can travel vast distances between stars. Furthermore, there's the idea that these objects could be remnants of star systems that are no longer in existence, either because the stars have died, or because their planets were destroyed in a catastrophic event. If this is the case, then interstellar objects could potentially provide us with clues about the fate of these distant systems. By studying their composition, movement, and trajectories, scientists might be able to reconstruct the history of these objects and the star systems they originated from. This could offer valuable insights into the life cycles of stars and planets, as well as the processes that lead to the formation and destruction of celestial bodies. As we continue to study objects like Oumuamua and Borisov, we are also pushing the boundaries of our technological capabilities. The ability to detect and study interstellar objects is no small feat. These objects are often small, faint, and move incredibly fast, making them difficult to observe and track. Yet, our growing understanding of space technology and our innovative approaches to observation are allowing us to capture more detailed information about these visitors from afar. In the future, we may even develop the ability to send probes to these objects, gathering samples and studying them up close. The potential discoveries are nearly limitless, and the mysteries surrounding these interstellar visitors may open doors to entirely new fields of scientific exploration. But for all the excitement surrounding interstellar objects, it's also important to acknowledge the challenges that come with studying them. Their transience is perhaps the most significant challenge. Unlike objects in our own solar system, which we can observe and study over extended periods, interstellar objects are passing through quickly, often only giving us a short window of opportunity to study them. This means that we have to be quick and precise in our observations, using advanced telescopes and computational models to capture as much data as possible before the object leaves our vicinity. Additionally, their unpredictable nature makes it difficult to prepare for their arrival. Unlike objects that follow established patterns, interstellar objects can appear unexpectedly, sometimes without warning, making it hard to plan ahead for their study. Despite these challenges, the study of interstellar objects is one of the most exciting frontiers in modern astronomy. These objects represent a bridge between our solar system and the vast, uncharted regions of interstellar space. They offer us a unique opportunity to explore a part of the universe that we would otherwise have no access to, and in doing so, they are helping us to reimagine the cosmos in new and unexpected ways. We may not yet have all the answers, but every new discovery about these objects brings us one step closer to understanding the mysteries of space and our place in it. As we continue to study objects like Oumuamua and Borisov, we will undoubtedly face more questions than answers. But that is what makes these objects so compelling. They are not just strange visitors from distant parts of the galaxy. They are the keys to unlocking some of the deepest mysteries of the universe. And as we delve deeper into their study, we will likely find that the universe is far more complex, interconnected, and full of surprises than we ever imagined. With each new interstellar object that comes our way, we are reminded that the mysteries of the cosmos are vast, and we have only just begun to scratch the surface. As we continue to unravel the mysteries surrounding interstellar objects, it's worth considering the implications of their very existence. These objects are not just random, unimportant pieces of debris drifting through space. They're relics from beyond our solar system, visitors from distant star systems that have journeyed through the interstellar medium for millions, if not billions, of years. Every single interstellar object that we encounter has its own story, a tale of its origin, its journey across the cosmos, and the forces that shaped its path. These objects serve as cosmic messengers, carrying information from the farthest reaches of the galaxy. And this isn't just a matter of curiosity. The study of these objects could be pivotal in expanding our understanding of astrophysics, planetary science, and even the potential for life elsewhere in the universe. Oumuamua and Borisov may only be the beginning. As we develop new methods and technologies to detect and study interstellar objects, it's very likely that we'll uncover a vast number of other interstellar travelers, some of which could reveal far more than we ever expected. We could find evidence of star systems that never formed planets, or perhaps remnants of stars that were destroyed in violent supernovae. We could even find clues to the formation of our own solar system, as these objects could carry within them the signatures of the early stages of solar system formation. One particularly intriguing aspect of interstellar objects is their composition. Unlike asteroids and comets from within our solar system, which are primarily made of materials that formed in the same environment as our planets, interstellar objects may have been created under entirely different conditions. They could contain elements or isotopes that are rare in our own solar system, or they could have been shaped by the gravitational influence of a different kind of star system. Imagine what we could learn if we found an object made of materials that are entirely foreign to us, substances that we've never observed before. This could radically expand our knowledge of chemistry, materials science, and even the processes that govern the formation of celestial bodies. Take the example of Oumuamua, which has already captured the imagination of scientists and the public alike. As the first confirmed interstellar object to be detected passing through our solar system, its peculiar shape, rapid velocity, and unusual trajectory sparked intense speculation about its origins. Was it a natural object, or could it have been an artificial creation? The truth, of course, remains unknown, but the fact that Oumuamua's trajectory didn't match the behavior of typical asteroids and comets led some to entertain the possibility that it could have been a probe or a piece of alien technology. While most scientists lean towards natural explanations, the debate surrounding its true nature underscores the point that these objects are far from ordinary. They challenge our assumptions about the universe and force us to think beyond conventional boundaries. This line of thinking has led to some fascinating new avenues of research. For instance, researchers are now considering the possibility that interstellar objects might carry microbial life, as mentioned earlier. The concept of panspermia, life traveling between planets, stars, and even galaxies, could be more than just a theory. If interstellar objects can travel vast distances across the galaxy, carrying with them organic molecules or even life forms, this could have profound implications for the possibility of life on other planets. Could Oumuamua and Borisov be carrying seeds of life from other star systems? And if so, could these life forms one day be capable of colonizing other planets, spreading across the galaxy in much the same way that life may have once spread throughout our own solar system? In this regard, the study of interstellar objects is also tied to the search for extraterrestrial life. As we continue to probe the outer reaches of our solar system, we're also looking for signs that life exists, or once existed, on planets and moons beyond Earth. The study of interstellar objects could offer a new angle on this search. By examining the chemical composition and structure of these objects, scientists might be able to identify signs of biological activity, or at the very least, the raw ingredients necessary for life to emerge. In essence, these objects could provide a window into the kinds of environments where life might thrive, as well as the processes that could lead to the formation of life. The discovery of these objects also has implications for our understanding of the future. Just as we study the movements and behaviors of interstellar objects to learn about their past, we can also look to them as indicators of what the future might hold. If the material that makes up these objects comes from star systems that no longer exist, this could offer clues about how our own star system might evolve in the distant future. Will our sun eventually become a red giant and shed its outer layers? Will the Earth be swallowed up in the process, or will life find a way to survive elsewhere in the galaxy? These are questions that may seem far off, but the study of interstellar objects could give us insights into the long-term fate of our solar system and other star systems. There's also the more immediate impact that these discoveries can have on space exploration. While we are still a long way from being able to send probes to distant interstellar objects, the discoveries we make about these objects could shape the way we think about the future of space exploration. As we push further out into the solar system and eventually beyond, the potential for encountering other interstellar objects becomes increasingly likely. Learning from our encounters with Oumuamua and Borisov could provide invaluable lessons about the challenges and possibilities of exploring objects that originate outside of our solar system. In the future, humanity may very well venture out to study these objects up close, sending spacecraft to interact with them and bring back samples for analysis. With all of this in mind, the mystery of interstellar objects is far from solved. We are only beginning to understand the complex nature of these cosmic visitors, and each new discovery raises more questions than answers. However, what is clear is that these objects have the potential to revolutionize our understanding of space, our place in the galaxy, and the origins of life itself. They are the messengers of the universe, carrying with them the stories of star systems long gone, and offering us a glimpse into the future of exploration and discovery. As we continue to observe and study these objects, we will undoubtedly uncover new mysteries and encounter new challenges that will keep us looking up at the stars in wonder and curiosity. Every time we look to the sky and catch sight of an interstellar object, we are reminded of how little we know about the vast expanse of space. These objects are a reminder that we are just a small part of something much larger, and that the universe is full of wonders we have yet to comprehend. From the mysteries of Oumuamua to the puzzling behavior of Borisov, these interstellar travelers invite us to question everything we thought we knew about the cosmos. And as we continue our quest for knowledge, we will undoubtedly find that the universe is far more strange and beautiful than we ever imagined. With each new discovery, we come one step closer to understanding the true nature of the cosmos and our place within it. As we continue to investigate the vast and largely unexplored world of interstellar objects, the story only grows more complex. With each new interstellar visitor, the questions multiply. We've only scratched the surface of understanding what these objects are, where they come from, and what secrets they hold about the universe's origins and its possible future. Beyond Oumuamua and Borisov, other potential interstellar objects remain to be discovered, adding to the growing mystery of how these space travelers journey from star system to star system, and what drives them along their seemingly random, yet remarkably precise paths. One of the most puzzling aspects of interstellar objects like Oumuamua is their ability to travel across vast distances. Their speed, their trajectory, and their apparent lack of gravitational interactions with the Sun are baffling. It's as though these objects were never meant to interact with our solar system at all, yet they found themselves crossing into our celestial neighborhood. This raises the possibility that interstellar objects are common visitors in our galaxy. Their presence in our solar system might be much more frequent than we realize, with many passing through undetected because they remain too small, too distant, or too faint to notice. In fact, some scientists have even suggested that there may be entire populations of interstellar objects hidden in the outer reaches of the galaxy. These objects could be remnants of distant star systems that were destroyed, or debris from the gravitational interactions between star clusters. With their erratic orbits and unpredictable velocities, these objects might hold the key to understanding the chaotic dynamics of the universe. And what if we could track more of them? What could we learn about the origins of these objects, or their paths through the cosmos? Theories about where these objects come from vary. Some scientists believe that interstellar objects could originate from star systems that are in the process of dying. For instance, when a star dies, its gravitational influence can cause surrounding planets and asteroids to drift away, leaving behind a trail of debris. This debris could travel for billions of years, eventually finding its way to our solar system. Other theories suggest that these objects could be the remnants of planetary systems that were destroyed in a supernova explosion. If that were the case, we would be seeing cosmic remnants of a long-dead star system, offering us a rare glimpse into the past of a once thriving system of planets. The most surprising thing about all of this is that these objects may not even belong to just one star system. Oumuamua and Borisov could have passed through many star systems on their journey to our solar system. They could have encountered gravitational forces from other stars or even passed close enough to other planetary systems to alter their course. In this sense, interstellar objects might be much more like cosmic vagabonds than travelers on a linear path from one star system to another. The fact that they've traveled so far through the harsh expanse of space, only to be captured by the gravity of our Sun, speaks to the extraordinary nature of their journey. At this point, we must ask ourselves, what's the significance of these interstellar travelers? Why are we only now beginning to discover them, after billions of years of cosmic history? Is it possible that they'd been visiting us all along, and we just never had the tools to detect them? Or is the discovery of these objects a sign that we are on the cusp of a new era in our understanding of the universe? The study of interstellar objects could also have practical implications for space exploration and the search for extraterrestrial life. While the idea that an object like Oumuamua could be an alien probe may be far-fetched, it raises interesting possibilities about what might be out there in the vast expanse of space. Could there be other objects out there, artificial or natural, that contain information about alien civilizations? Could a future mission to an interstellar object reveal more than we bargained for, offering up clues about life elsewhere in the galaxy? As we continue to search the cosmos for more interstellar objects, it's clear that our exploration of the universe is just beginning. The technologies we develop to detect these objects, along with our growing understanding of their behavior, will open up new avenues of inquiry. Scientists are already working on building better telescopes and instruments that can help us track and study these objects in greater detail. For example, the upcoming James Webb Space Telescope is expected to be able to detect objects that are even more faint and distant than those that have been observed so far. As technology advances, our ability to spot interstellar visitors will only improve, allowing us to keep pace with the ever-growing mystery of their origins and significance. But even with the advances in technology, we may never fully understand the true nature of these objects. They come from regions of space that are beyond our reach, and their paths are influenced by gravitational forces that we are only beginning to understand. They are objects of immense interest, but also objects of great mystery. In many ways, they are the perfect symbol of our quest for knowledge in a universe that is often unknowable. We're left with the undeniable fact that interstellar objects are one of the greatest mysteries of space. Their origins, their journeys, and their implications for our understanding of the cosmos remain largely unknown. But one thing is certain: they are not just random, insignificant bits of space dust. They are clues to a greater puzzle, a puzzle that spans billions of years and stretches across the vastness of space. Whether they are relics of ancient star systems, harbingers of future discoveries, or something else entirely, interstellar objects are bound to continue to capture our imagination and push the boundaries of what we know about the universe. The discovery of Oumuamua and Borisov has opened up a new chapter in the story of space exploration. They've shown us that the universe is more mysterious and more complex than we ever thought possible. And as we continue to investigate these interstellar travelers, we will undoubtedly learn more about the history of our galaxy, the nature of space, and the very building blocks of the cosmos. The journey to understanding these objects may take us decades or even centuries, but one thing is certain: the mysteries of interstellar objects are far from over. As we look forward into the future of interstellar object exploration, the realm of possibilities expands ever further. With new technological advances and discoveries happening on a seemingly daily basis, we stand at the threshold of potentially groundbreaking revelations. It's easy to forget that just a few years ago, Oumuamua's arrival in our solar system was met with skepticism, uncertainty, and excitement all at once. Yet, as time goes on and more data is collected, the narrative of interstellar objects has only gained more layers, opening new doors to questions we never even thought to ask before. Let's focus for a moment on the question of how we could explore these objects in greater detail. Given the great distances these objects travel, getting there is no small feat. Current space exploration technology simply isn't capable of launching missions to these distant visitors in any meaningful time frame. After all, Oumuamua was moving at over 196,000 miles per hour when it passed through our solar system, a speed that's difficult to comprehend, let alone match with our current spacecraft. The New Horizons probe, which famously visited Pluto in 2015, took over 9 years to travel just a fraction of the distance that Oumuamua covered in a matter of months. However, this doesn't mean that interstellar object exploration is beyond our reach. In fact, the idea of sending probes to interstellar objects is being actively discussed in the scientific community. There are proposals to develop next-generation spacecraft capable of reaching these distant visitors. One promising concept is the use of solar sails, thin, reflective materials that could be propelled by the pressure of sunlight. Solar sails have been tested in small-scale prototypes, and while we're still a long way from sending a solar sail probe to the farthest reaches of the galaxy, the potential is immense. The breakthrough project known as Breakthrough Starshot is an example of how technology might evolve to explore interstellar space. The project aims to send tiny, lightweight spacecraft propelled by lasers to the closest stars, with the goal of achieving speeds up to 15 to 20% of the speed of light. If successful, Breakthrough Starshot could potentially reach the nearest interstellar objects in a matter of decades, rather than millennia. While we're not there yet, the very idea that we could one day explore these interstellar visitors up close is enough to stir the imagination. The question of whether we'll be able to physically study interstellar objects up close is certainly one of the more speculative aspects of this topic. However, in the meantime, our best tools for understanding these objects are our telescopes and observatories. These instruments allow us to gather a wealth of information about the size, shape, composition, and trajectory of interstellar objects. As technology advances, we'll be able to gather more and more detailed data, unlocking new insights into their origins and behavior. In addition to telescopes, there are a number of theoretical models that scientists use to try to understand the behavior of interstellar objects. For instance, the trajectory of Oumuamua was closely examined by astronomers when it passed through the solar system. The initial excitement around its unusual motion, coupled with the fact that it appeared to accelerate without the expected gravitational influences from the Sun, led to a variety of speculative theories. Some suggested that Oumuamua could be a comet with an unusual composition, while others proposed that it could be a probe sent by an advanced civilization. Though the latter idea is often dismissed as far-fetched, it speaks to the curiosity and fascination that these objects inspire. As more interstellar objects are discovered, we'll have a greater data set to work with, allowing scientists to refine their models and theories. By analyzing the characteristics of these objects, such as their speed, shape, and the way they interact with light, scientists can better understand the processes that shape them and the forces at play as they travel across the cosmos. As we continue to observe these objects, new questions will undoubtedly arise. Could there be patterns in their movements? Are some of them linked to certain regions of space, suggesting a common origin? These are the questions that drive scientific exploration and will likely guide future investigations into the nature of interstellar objects. Another fascinating possibility is that interstellar objects may offer us clues about the formation of our own solar system. Just as meteorites and comets have been valuable tools for understanding the early solar system, interstellar objects may be remnants of ancient systems that have long since passed away. Studying their composition could give us a snapshot of the conditions that existed in distant star systems billions of years ago, before they were swallowed by the darkness of interstellar space. By comparing the chemical makeup of these objects with that of our own solar system, we could uncover new insights into the processes that led to the formation of planets, moons, and the building blocks of life. Of course, there's also the possibility that interstellar objects could contain information about the broader cosmos, not just our solar system. These objects have traveled across the galaxy, passing through regions that are light years away from our location. As they journey through space, they may be exposed to cosmic radiation, magnetic fields, and other phenomena that we haven't yet fully understood. The data they carry could be invaluable in helping us piece together a more complete picture of the universe, from its earliest moments to its current state. There's one more thing that makes interstellar objects so intriguing: their potential connection to life. While we have yet to discover definitive evidence of extraterrestrial life, the possibility that an object like Oumuamua could be an alien probe remains a tantalizing thought. As unlikely as it may seem, the idea that an object from another star system could carry a message, or even represent an intelligent civilization, sparks our imagination. While this remains purely speculative, it's a reminder that space is full of mysteries we've yet to uncover. The study of interstellar objects is one of the most exciting and enigmatic frontiers of modern science. These visitors from beyond our solar system have sparked our curiosity and challenged our understanding of the universe. From their strange movements to their potential origins, interstellar objects offer us a glimpse into the unknown, a window into the distant reaches of space that we've only just begun to explore. As we continue to develop the technology and tools necessary to study these objects, we can only imagine the discoveries that lie ahead. Perhaps one day, we'll be able to send a spacecraft to one of these objects to learn firsthand what lies within. Or perhaps, as technology advances, we'll find ourselves looking to the stars, not just with the hope of discovering new worlds, but with the knowledge that there are objects out there, objects that have journeyed across the galaxy, waiting for us to unlock their secrets. The future of interstellar exploration is still in its infancy, but it's a future that holds endless possibilities. Each new discovery brings us one step closer to understanding the vast and mysterious cosmos in which we live. The story of interstellar objects is far from over, and as we continue to look outward, we may just uncover the answers to some of the most profound questions in science. As we venture deeper into the study of interstellar objects, there are other facets to explore, some of which verge into the realm of pure speculation, while others hold the potential for groundbreaking discoveries. Let's now consider the technological advancements that could one day allow us to better understand and possibly interact with these objects. First, it's important to recognize that our current understanding of space travel is still in its early stages, especially when compared to the vast distances we are talking about. Even with our fastest spacecraft, such as the Parker Solar Probe, which can travel at speeds nearing 430,000 miles per hour, we would need thousands of years to reach even the nearest stars. This is the magnitude of the challenge we face when trying to explore interstellar objects up close. Therefore, the future of space exploration must be revolutionized if we are ever to reach these cosmic visitors in any meaningful way. One of the most promising approaches being discussed in the scientific community is the use of artificial intelligence, AI, and machine learning. These technologies could potentially help us analyze vast amounts of data collected from telescopes and space probes, enabling us to identify patterns that were previously invisible. AI could also be used to design new spacecraft, and even aid in the navigation of probes that could be sent to study these distant objects. Imagine a future where an AI-controlled spacecraft is launched to study an interstellar object, autonomously adjusting its course in real time based on the data it collects. While this may sound like science fiction today, AI's rapid advancements make it a very real possibility for the future. Furthermore, the concept of utilizing robotic exploration should not be overlooked. Robots, unlike humans, can endure the harsh conditions of space for much longer periods. They are also far less susceptible to the physical toll that long-term space travel would have on the human body. As such, robotic missions could serve as the vanguard in exploring interstellar objects. These robots could be equipped with advanced sensors, cameras, and instruments designed to analyze the composition, structure, and even potential signs of life on these objects. They could also send data back to Earth in real time, providing us with an unprecedented look at these visitors from other star systems. While the technological aspect is certainly exciting, we must not lose sight of the scientific implications of studying interstellar objects. The most obvious and perhaps the most tantalizing possibility is that these objects could hold the key to answering one of the greatest questions in science. Are we alone in the universe? While it's important to note that the idea of interstellar objects being evidence of alien civilizations is far from certain, the sheer fact that we are receiving visitors from other star systems opens up an entirely new area of exploration in the search for extraterrestrial life. The possibility of life beyond Earth is one of the most profound questions humanity has ever faced. For centuries, scientists have pondered the existence of life on other planets. We've studied our own solar system, looking for signs of life on Mars, Europa, and Enceladus, moons of Jupiter and Saturn that harbor subsurface oceans. But what if life isn't confined to our solar system? What if the answer lies in objects that have traveled across the vast distances of interstellar space? It's a tantalizing thought, but we must be cautious not to leap to conclusions. While the idea that Oumuamua could be an alien probe was widely speculated upon, the more likely explanations center around natural phenomena. Nevertheless, the fact that we have no definitive answers only adds to the mystery. Could there be other interstellar objects that carry with them the building blocks of life, or perhaps even life itself, in some form? What would it mean if we discovered that the very fabric of life could exist beyond Earth, in the farthest reaches of space? One aspect that often goes overlooked is the importance of these interstellar objects in shedding light on the nature of our universe's evolution. Our solar system was formed billions of years ago, and while we've learned a great deal about its origins, we still don't fully understand how other star systems and galaxies came into being. Interstellar objects, by virtue of their journey across vast stretches of space, could be relics of other systems that formed under very different conditions. These objects might contain clues about how stars and planets are born in other parts of the universe. For instance, by analyzing the composition of objects like Oumuamua, scientists could potentially learn more about the types of materials and molecules that were common in other star systems. This could lead to a better understanding of the conditions that give rise to planets and stars and help us determine whether life could have evolved elsewhere under similar conditions. One of the mysteries surrounding Oumuamua was its unusual shape and its accelerated motion as it passed through the solar system. While some have suggested that this acceleration could be the result of alien technology, others have proposed more natural explanations, such as the possibility that the object was a fragment of a larger comet or asteroid that had been torn apart. Its elongated shape, which was unlike anything we'd seen before, sparked a great deal of debate among scientists. Could it be that Oumuamua is simply a cosmic fragment, a remnant of a star system that had been destroyed in a supernova or a collision with another object? Could its unusual motion be the result of forces we don't yet fully understand? The mystery of Oumuamua's origin is far from solved, but as more interstellar objects are discovered, scientists are piecing together a more detailed picture of their nature and behavior. For example, the recent discovery of the Comet Borisov, which was the second interstellar object to be observed passing through our solar system, provided further insight into the composition and characteristics of these objects. Borisov appeared to be more typical of a comet than Oumuamua, displaying a classic tale of gas and dust as it passed through the solar system. Its discovery confirmed that interstellar objects are not just rare anomalies, but may be a more common feature of our universe than previously thought. As our technology improves and we continue to observe these objects, we will undoubtedly learn more about their nature and origins. We may even discover that these objects are not unique, but part of a larger population of interstellar visitors that pass through our solar system on a regular basis. This would have profound implications for our understanding of the universe. It would suggest that the solar system is not an isolated system, but rather part of a vast network of stars and objects that are constantly interacting with one another. This raises yet another intriguing possibility. Could interstellar objects be more than just visitors? Could they be messengers, carrying data, materials, or even life across the galaxy? While this idea remains speculative, it speaks to the enduring fascination with the idea of Panspermia, the theory that life could be distributed across the cosmos through the movement of cosmic debris. If interstellar objects are more than just wanderers, if they are in fact carriers of life or information, then the implications for our understanding of the universe and our place in it would be truly staggering. Ultimately, the study of interstellar objects like Oumuamua and Borisov opens up new frontiers in our quest to understand the universe. These objects challenge our existing theories and invite us to ask questions we never thought to ask. While we may not have all the answers today, every discovery brings us one step closer to unlocking the mysteries of the cosmos. As we continue to investigate these interstellar visitors, we must not underestimate the vast amount of unknowns that lie ahead. The study of these objects is not only a matter of understanding our cosmic neighborhood but also about expanding the very boundaries of human knowledge. To understand these phenomena fully, we must approach them with both a scientific mindset and an open mind, as the possibilities could challenge everything we thought we knew about space, time, and even life itself. One of the most pressing questions raised by interstellar objects is how they interact with the larger structure of the universe. These objects travel through the Milky Way at incredible speeds, and their paths are influenced by the gravitational forces of stars, black holes, and even the dark matter that permeates the galaxy. By studying how these objects move, we can learn more about the unseen forces that shape the cosmos. For example, we know that our galaxy is not a static structure, it is constantly in motion, with stars and other celestial objects moving through space. Understanding the paths of interstellar objects could provide clues about the larger dynamics at play in the galaxy, including the influence of dark matter and dark energy. Another intriguing aspect of studying interstellar objects is the opportunity to learn about the formation of planetary systems beyond our own. The materials and chemical compositions found within these objects could reveal how other star systems form and evolve. It could be that the building blocks for life as we know it are not unique to Earth but are distributed throughout the universe. This idea, often referred to as cosmic evolution, suggests that life could have the potential to emerge on planets in other star systems, even if those systems are vastly different from our own. Take, for example, the discovery of organic molecules within comets and asteroids in our solar system. These molecules are some of the fundamental building blocks of life, and their presence on interstellar objects suggests that the ingredients for life might be far more widespread than we previously thought. If the materials found in Oumuamua and Borisov share any similarities with those found in our own solar system, it could be an indication that the universe has a common set of ingredients that allow life to take shape in different places, under different conditions. This would add a new layer of depth to our understanding of life's potential across the cosmos. Moreover, by studying interstellar objects, we also gain insights into the nature of their parent star systems. Just as our solar system was shaped by the interactions of the Sun with its surrounding planets, moons, and comets, the parent systems of these interstellar objects may offer a window into a different way of forming planets, stars, and potentially life. Could there be systems out there that are radically different from our own? The discovery of even more interstellar objects could give us the first glimpse into systems we can't directly observe. Through them, we may begin to uncover the diverse processes that govern star formation, planet development, and the potential for life in the universe. A particularly interesting point raised by the study of objects like Oumuamua and Borisov is the possibility that we may one day be able to detect signatures of advanced civilizations on these objects, assuming they are engineered and not entirely natural. While such ideas remain speculative, the notion that interstellar objects might be artificial in nature opens up the discussion about the potential existence of advanced extraterrestrial civilizations. Could these objects be a form of communication, a sort of cosmic message in a bottle, sent across the galaxy by an intelligent species, meant to be discovered by others? Some scientists, like Avi Loeb, have argued that Oumuamua's unusual properties, such as its acceleration and shape, could point to it being an artificial probe, perhaps sent by an extraterrestrial civilization for reasons we can't yet fathom. The challenge with such speculations, of course, is that they are difficult to test and remain largely in the realm of science fiction, but it's precisely this kind of thinking that pushes the boundaries of human understanding. If we do find more interstellar objects in the future, scientists may be able to gather more evidence to support or refute such ideas. Until then, the possibility of finding a signal or a clue that points to extraterrestrial intelligence remains one of the most thrilling prospects in science. One area of potential research that could help unravel these mysteries is the development of more powerful telescopes and observational techniques. While current telescopes like the Hubble Space Telescope and the Atacama Large Millimeter Array, ALMA, have given us a wealth of information, the next generation of observatories could revolutionize our understanding of interstellar objects. Telescopes like the James Webb Space Telescope, scheduled for launch in the near future, will allow scientists to observe objects in infrared wavelengths, giving us a better understanding of their composition, structure, and origins. Similarly, the development of larger and more sensitive detectors could help us spot objects that are currently too faint or too far away to be detected with existing technology. As our instruments become more advanced, we may soon be able to observe interstellar objects in real time, as they pass through our solar system, allowing us to study them in unprecedented detail. In the meantime, our exploration of the cosmos continues to raise more questions than answers. The discovery of objects like Oumuamua and Borisov reminds us of how much we still have to learn about the universe. Every time we uncover a new mystery, we realize that there is still so much more to explore, to observe, and to understand. The truth is, while we've made incredible strides in our knowledge of space, we are still only scratching the surface. So, where does that leave us? In many ways, we are on the brink of an exciting new era of discovery. The study of interstellar objects holds the potential to answer questions that have intrigued humanity for centuries. How did the universe come to be? Are we alone in the cosmos? What are the forces that govern the behavior of objects in space, and how do they shape the universe we see today? These questions are not just academic, they are fundamental to understanding our place in the grand scheme of the universe. And who knows? The next interstellar object to visit our solar system could hold the key to unlocking some of these mysteries. Perhaps it will reveal something we never expected, something that completely changes the way we think about the cosmos. For now, we continue to watch, to study, and to learn. As we do, the mysteries of interstellar objects will undoubtedly continue to fascinate and challenge us, pushing the limits of what we know and opening up new frontiers for future exploration. As we venture further into the realm of interstellar objects, it's essential to recognize how these discoveries push the very boundaries of our scientific frameworks. The fact that such objects can traverse the immense void between stars without being fully understood by us speaks volumes about the mysteries that lie beyond our comprehension. Every new interstellar visitor, such as Oumuamua and Borisov, presents us with new challenges, forcing us to re-examine our assumptions about the nature of space, time, and even the building blocks of the universe itself. One of the most intriguing aspects of these objects is their potential to reshape our understanding of solar system dynamics. When Oumuamua first entered our solar system, scientists had to confront the fact that it did not behave like anything seen before. Unlike a typical comet or asteroid, Oumuamua exhibited peculiar acceleration, leading many to question whether it was affected by forces beyond what we typically associate with gravitational influences. Was it propelled by an unknown force? Could there be a natural explanation for this behavior that we simply haven't discovered yet? Or could it be evidence of something more radical, like a deliberately engineered object from an extraterrestrial civilization? While the more outlandish theories involving alien technology have attracted attention, the scientific community has not completely dismissed the possibility that Oumuamua could be a natural object with yet-to-be understood properties. The question of its propulsion has led to proposals such as the possibility that it might be a hydrogen iceberg, a kind of icy comet composed of frozen hydrogen, a substance that behaves differently from more common materials. Others have suggested that the object might be a fragment from a much larger interstellar collision, a piece of debris left over from a cosmic event. Whatever the ultimate explanation may be, the fact that Oumuamua defied easy categorization reflects a larger reality in space exploration. Our current models are still far from complete. The universe, it seems, does not care for the neat boxes we tried to place it in. When a phenomenon like this occurs, it forces us to rethink everything, from our theories of how objects move through space to the possibility that we may not know everything about how stars, planets, and objects interact across light years of distance. As we look toward future interstellar objects, the tools at our disposal are improving rapidly. With the advancements in technology, telescopes and observatories will allow us to capture more data and begin to identify more of these mysterious travelers before they even reach our solar system. The PanSTARRS, Panoramic Survey Telescope and Rapid Response System, project and the upcoming Vera-C, Rubin Observatory are already playing a crucial role in detecting near-Earth objects, and the next few years will undoubtedly yield even more discoveries in this field. These technological advancements are not just about counting objects, they are about understanding them. Scientists are hoping that with better data, they can begin to uncover patterns or commonalities that might suggest broader, unifying principles about the nature of interstellar objects. For instance, could there be a relationship between the properties of these objects and the conditions in their home star systems? Are they the remnants of something much older, having traveled for millions of years before arriving in our neck of the galaxy? Or are they a new type of object entirely, offering a glimpse into phenomena that we didn't even know existed? By unlocking the answers to these questions, we may learn more about the types of stars, planets, and moons that exist in other parts of the universe, potentially shedding light on the conditions under which life could emerge elsewhere. Could there be a connection between the materials found in these objects and the chemical processes that lead to the formation of life? Could these interstellar objects be carrying the seeds of life, or even be remnants of ancient lifeforms that once existed in far-flung star systems? The very idea is tantalizing, and while it remains speculative, it's a concept that warrants further investigation. But not all of the mysteries surrounding interstellar objects are related to the question of life. Some are more fundamental and physics-based, touching on questions about the nature of gravity, motion, and energy. For example, why do interstellar objects like Oumuamua and Borisov behave differently from objects in our solar system? Are they following the same laws of physics, or do they offer evidence of unknown forces or interactions that exist beyond the gravitational influence of stars? The movements of these objects are also a key point of interest. Both Oumuamua and Borisov followed unexpected paths as they passed through the solar system, which led scientists to consider a range of possible explanations. While gravitational forces from the Sun and planets typically influence the paths of objects, the trajectories of these interstellar objects didn't quite match what was predicted. In the case of Oumuamua, its speed increased as it passed through our solar system, and this acceleration was not easily explained by the forces at play in the system. Some scientists have suggested that a comet-like release of gas might have been the cause, while others think that the object could have been pushed by radiation pressure from the Sun. Such anomalies are not just curiosities. They are clues to a deeper and more profound understanding of the universe's mechanics. If we can figure out why these objects behave differently, we might uncover new physical phenomena that exist throughout space, potentially leading to breakthroughs in our understanding of the laws of nature. This is why the study of interstellar objects is not just about understanding those particular objects themselves, but about investigating the underlying forces that govern all matter and energy across the cosmos. To truly appreciate the significance of these objects, one must also consider their role in the grander narrative of cosmic exploration. For centuries, humanity has gazed up at the night sky with wonder, asking questions about the stars, planets, and the possibility of life beyond Earth. With the discovery of objects like Oumuamua and Borisov, we are no longer simply speculating. We are standing on the precipice of answering questions that have fascinated us for millennia. These objects represent the beginning of a new chapter in our exploration of the universe, one where the answers are not only coming faster but are also opening up new doors to even greater mysteries. In the future, as we continue to track and study more interstellar visitors, we might gain insights into far more than we ever anticipated. These objects are like cosmic messages in bottles, drifting through the void from distant star systems, telling stories of places we will never visit, at least not in the near future. Yet, in a way, they connect us with those distant places, allowing us to piece together the puzzle of the universe, one fragment at a time. The mystery of interstellar objects is far from solved, but as we continue to explore, one thing becomes clear: the universe is much more mysterious, much more complex, and much more connected than we ever imagined. The interstellar objects that enter our solar system are, in a sense, like messengers from faraway lands, carrying information about their place of origin. By studying their chemical composition, shape, and behavior, scientists can infer details about the regions of space they've traveled through and the star systems they've come from. These objects are not just passive visitors. They are like clues that tell us about the nature of interstellar space itself. Consider the case of Oumuamua, the first confirmed interstellar object to pass through our solar system. Beyond its strange trajectory and the mystery of its acceleration, the object's shape was another source of intrigue. It was long and cigar-shaped, unlike any asteroid or comet observed before it. Its elongated form, along with its unusual brightness, raised questions about its physical properties. How could an object of this size, with such an unusual shape, travel through space at high speeds? What material was it made of, and how could it maintain its integrity during its long journey across the stars? Scientists have proposed several theories to explain the object's peculiarities. One hypothesis is that it could be a fragment of a larger, more complex object, broken apart by the forces it encountered in its travels. Others have speculated that it might be a type of cosmic debris left behind from the formation of a distant star system. However, no one theory has been able to fully explain all of the object's oddities. This ongoing mystery only adds to the excitement and wonder surrounding interstellar objects. If Oumuamua's origin is truly unlike anything we've seen before, then what does that say about the variety of objects and phenomena that exist beyond our solar system? As for Borisov, the second interstellar visitor to pass through our solar system, it was a more traditional comet, yet it still raised important questions. Unlike Oumuamua, Borisov displayed typical cometary behavior, such as the development of a tail as it approached the Sun. However, even Borisov's behavior challenged our assumptions about comets. Its path, too, was unusual. It came from a direction in the sky that was not aligned with the galactic plane of our Milky Way. This has led some scientists to wonder whether the object's trajectory and speed suggest that it could have come from a different galaxy entirely. While this is still a matter of debate, the fact that Borisov's path was so different from what we expected further emphasizes the unpredictability of interstellar objects. Borisov's visit was also significant because it provided us with a rare opportunity to study an interstellar object up close. During its time in our solar system, astronomers were able to observe its composition and behavior in detail, gathering valuable data about the nature of interstellar comets. Like Oumuamua, Borisov's passage through the solar system offered new insights into the dynamics of objects traveling between the stars. While its characteristics were more in line with what we've come to expect from comets, the fact that it was from another star system was a groundbreaking discovery in its own right. It proved that such objects are not just theoretical curiosities, but actual, measurable phenomena that can be studied and understood. Both Oumuamua and Borisov highlight a crucial aspect of space exploration, the need for constant vigilance and observation. These objects arrived without warning, and in both cases, their discovery was a stroke of luck. If we hadn't been paying attention, we might have missed them entirely. This brings to the forefront the importance of programs like Pan-STARRS and other sky surveys, which are continually scanning the heavens for any objects that might pose a threat or offer new scientific insights. These programs are our eyes in the sky, providing early warnings of potential hazards and helping us uncover the hidden treasures of the universe. The discovery of interstellar objects also raises the question of how many more of them are out there, waiting to be discovered. The universe is vast, and the likelihood that we've observed all the objects that have passed through our solar system is low. In fact, there are probably many more objects like Oumuamua and Borisov out there, passing through our solar system unnoticed, simply because they haven't been detected in time. As our observational tools improve, we are likely to uncover more of these interstellar visitors, each one offering new puzzles to solve and mysteries to unravel. The implications of these discoveries extend far beyond just the realm of astronomy. If these objects are indeed visitors from distant star systems, they might carry with them important information about the conditions of their home stars, planets, and the potential for life elsewhere in the universe. In the future, we may be able to use interstellar objects to learn more about the types of exoplanets that exist around other stars, the composition of distant star systems, and even the potential for life to arise in environments that differ from our own. These objects could be the first signs of life beyond Earth, or they could simply be fascinating relics of the universe's past. The study of interstellar objects is also forcing us to reconsider our understanding of the cosmos. For example, the discovery that objects like Oumuamua can travel between star systems suggests that the galaxy is not as isolated as we once thought. Objects may be moving between star systems, exchanging material and information in ways that we haven't yet fully understood. This interconnectedness of the galaxy challenges our traditional view of the universe as a vast, empty expanse between the stars, and opens up new possibilities for the exchange of material and energy on a galactic scale. In a broader sense, the exploration of interstellar objects is a testament to humanity's curiosity and drive to explore the unknown. Just as our ancestors set out to explore the Earth's oceans, we are now venturing into the depths of space, seeking out new frontiers and new discoveries. Each interstellar object that passes through our solar system is a reminder of how much there is left to learn about the universe, and how far we have yet to go in our understanding of the cosmos. The study of these objects is a journey that will continue to captivate and challenge scientists for years to come, and it is one that promises to reshape our understanding of the universe in ways we can only begin to imagine. The mystery of interstellar objects is far from over, and as we continue to make new discoveries, we will likely encounter even more strange and perplexing visitors from beyond our solar system. These objects are not just scientific curiosities. They are windows into the unknown, offering glimpses of the wonders and mysteries that lie waiting for us in the far reaches of the galaxy. Each discovery brings us closer to understanding the forces that shape the universe and the origins of the objects that populate it. And in the end, the true significance of interstellar objects may be not only in what we learn from them, but in the way they inspire us to keep searching, to keep exploring, and to keep pushing the boundaries of our knowledge. The vastness of interstellar space, the region between the stars, has always been a source of wonder and mystery. It's a place that seems almost inhospitable, a void between stars that many scientists once believed was completely devoid of any substantial objects. But as the discovery of interstellar objects like Oumuamua and Borisov shows, this is far from the truth. Interstellar space, in fact, is full of moving bodies, particles, and phenomena that we're only beginning to comprehend. These objects challenge our understanding of the solar system's boundaries and the nature of interstellar travel. And yet, these strange visitors raise more questions than answers, leaving scientists to wonder, are they simply passing through, or is there something deeper, more profound, to these objects than we can see at first glance? As we continue to study these interstellar travelers, the mysteries they present become more complex and far-reaching. For example, one of the questions raised by objects like Oumuamua is, what else is out there? Could there be other objects like it, yet to be discovered, just beyond our observational reach? The vastness of space makes it difficult to track every potential object, and some of these visitors may pass through without leaving any trace. Even with the most advanced telescopes and sky surveys, there's always the possibility that we've missed something truly extraordinary, an object that could change our understanding of the cosmos. This uncertainty is a driving force behind much of the excitement surrounding the study of interstellar objects. Each new discovery offers a new piece of the cosmic puzzle, bringing us one step closer to answering fundamental questions about the universe. Are interstellar objects like Oumuamua and Borisov simply fragments of larger objects, or are they the remains of entire star systems, destroyed and scattered by cataclysmic events? Could they hold the key to understanding the processes that govern the birth, evolution, and death of stars and planets? In many ways, interstellar objects are like messengers from distant worlds, telling us stories of other stars, other systems, and other parts of the galaxy. But these messages are not always clear, and the answers we seek may not come easily. For instance, the unusual acceleration of Oumuamua puzzled astronomers for months. While some speculated that the object's speed was due to the outgassing of volatile materials, others wondered if it was the result of some unknown force. Could it be that the object was not just a passive traveler, but something with a purpose, sent from another civilization, or at least altered in ways that defied our understanding of natural forces? Though some of these ideas may seem far-fetched, the mystery of Oumuamua shows us just how much we still have to learn about the universe. Even the most seemingly straightforward phenomena can present unexpected challenges. As technology advances and our tools for observation become more refined, we are likely to uncover even more interstellar visitors, each one offering us a new chance to probe the unknown and expand the boundaries of our knowledge. The potential for these objects to offer insights into the nature of life and the conditions necessary for its existence is another exciting avenue of research. Some scientists speculate that objects like Oumuamua could be carrying material from planets or moons where life might have developed, whether in the form of simple microbes or more complex organisms. If life could exist in the extreme conditions of interstellar space, what other forms of life might be thriving in the farthest reaches of the galaxy, waiting for us to find them? While we may not yet have definitive answers, the possibility that interstellar objects could contain clues about the origins of life adds an entirely new dimension to the study of space. These objects are more than just floating debris, they could be the harbingers of something much more profound. Perhaps, in the future, as we continue to examine the chemical and physical makeup of these objects, we will find signs of life that have traveled across the stars, just as we now look for signs of life on distant exoplanets. As we delve deeper into the study of interstellar objects, we begin to confront the broader questions about the nature of the universe itself. For example, why do these objects come from such distant places? How do they travel across vast distances, defying the limitations of our current understanding of space travel? The speed and trajectories of objects like Oumuamua and Borisov suggest that the processes governing the movement of interstellar bodies are vastly more complex than anything we've encountered within our solar system. Could these objects be part of a larger, unknown cosmic process, something that connects distant stars and systems in ways that we've yet to understand? The mystery surrounding interstellar objects is also bound up with the larger question of the future of space exploration. As our technology advances, we are beginning to look beyond the boundaries of our own solar system. Projects like the breakthrough Starshot initiative, which aims to send tiny spacecraft to the nearest stars, are beginning to push the limits of what's possible in space travel. Could the study of interstellar objects like Oumuamua help us unlock the secrets of faster-than-light travel, or provide new insights into how to send probes to other star systems? The study of these interstellar visitors may also offer new insights into the future of our own solar system. Just as we've seen objects like Oumuamua and Borisov pass through our cosmic neighborhood, could it be that, one day, our solar system might become the home of an interstellar traveler? It's a fascinating possibility that raises more questions about the future of our planet and the broader fate of the solar system. The idea of interstellar objects passing through our solar system also highlights the dynamic, ever-changing nature of the cosmos. Just as the stars and planets of our solar system move and evolve over time, so too do the objects that come from beyond. These visitors remind us that the universe is not a static, unchanging place, but a constantly shifting, evolving system full of surprises and mysteries. Each time an object like Oumuamua or Borisov appears, it's like a cosmic puzzle, offering us a glimpse into a world we've never seen before. One of the most exciting aspects of studying these objects is the opportunity to peer into the unknown. Each discovery raises more questions, but also brings us closer to understanding the vast, interconnected web of objects that populate our galaxy. Whether it's a fragment of a destroyed star system, a wandering comet, or something far stranger, interstellar objects are challenging our assumptions about the nature of the universe and our place within it. As we continue to investigate these cosmic visitors, we can only imagine what new insights and discoveries await us. The study of Oumuamua, Borisov, and other interstellar objects is just the beginning of a new chapter in space exploration. Each object that crosses our path is a reminder that the universe is far more complex and wondrous than we could ever have imagined. As we continue our exploration of interstellar objects, we begin to realize just how much we still don't know about the vast reaches of space. These objects that enter our solar system offer a unique opportunity to study the outermost realms of the galaxy. The scientific community has only just begun to scratch the surface in understanding the true nature of these visitors. And while each new discovery is exciting, it also raises even more questions, leaving us with a deep curiosity that pushes us to explore even further. One of the fascinating aspects of interstellar objects like Oumuamua and Borisov is that they offer us a glimpse into a part of the universe that we've never been able to observe directly before. While we have studied the solar system extensively, the rest of the galaxy is far more elusive. The study of these objects may unlock hidden truths about how the Milky Way operates, shedding light on the forces that shape stars, planets, and everything in between. When Oumuamua was first discovered, its strange behavior sent shockwaves through the scientific community. For one, its unusual trajectory was unlike anything seen before in the solar system. It seemed to be accelerating in ways that didn't make sense. As it passed through our solar system, astronomers noticed that it wasn't behaving like a typical comet or asteroid. Instead of following a predictable orbital path, Oumuamua seemed to be moving faster than expected. This unexpected acceleration was one of the key mysteries surrounding the object. At first, scientists believed that the acceleration could be explained by the outgassing of volatile materials. Comets, after all, are known to release gas and dust when they approach the Sun, creating a thrust that pushes them forward. However, further analysis of Oumuamua's movements revealed no sign of any visible outgassing. This led some researchers to propose even more outlandish ideas, such as the possibility that Oumuamua was a type of light sail, an artificial object propelled by radiation pressure from the Sun. This theory, while fascinating, has not been universally accepted. However, it serves as a prime example of how an interstellar object can challenge our preconceived notions of physics. But Oumuamua wasn't the only interstellar object to raise eyebrows. Borisov, the second known interstellar object to pass through our solar system, was discovered in 2019, just 2 years after Oumuamua. While it didn't exhibit the same bizarre acceleration, Borisov was still an object of immense interest to scientists. A comet originating from another star system, Borisov was a rare opportunity to study an object that had never before interacted with the Sun. Its chemical composition, trajectory, and behavior could reveal new information about the conditions that exist in other star systems and offer insights into the formation of comets and planetary bodies. What's particularly interesting about Borisov is that it was a more typical comet compared to Oumuamua. It displayed the characteristic tail of gas and dust that we expect from comets in our own solar system. But even though it behaved more like a typical comet, the fact that it came from another star system still held profound implications. By studying its chemical composition, scientists were able to gain a better understanding of the building blocks that may exist in other parts of the galaxy. This knowledge could help us answer fundamental questions about the formation of planetary systems and the potential for life elsewhere in the universe. These two objects, Oumuamua and Borisov, represent the tip of the iceberg when it comes to interstellar exploration. As our telescopes and technology improve, we may soon be able to identify many more such objects. In fact, some scientists believe that there could be thousands of interstellar objects passing through our solar system at any given time, objects too small or too faint to detect with our current instruments. The discovery of more interstellar objects will undoubtedly open up new avenues of research, providing us with invaluable data about the nature of the galaxy. The study of interstellar objects also opens the door to a broader understanding of the forces at play in the universe. These objects are the result of gravitational interactions between stars, the remnants of stellar processes, and even the possibility of planetary systems being ejected from their home star systems. In this way, interstellar objects are like cosmic travelers, hitching rides on the gravitational currents that shape the movement of stars and planets. One of the most profound implications of these objects is the idea that the galaxy itself is far more interconnected than we may have originally thought. In the past, scientists believed that the stars and planets in our galaxy were isolated, each one existing in its own little corner of the universe. But the discovery of interstellar objects challenges that view. These objects are proof that material is constantly moving between star systems, that there are forces at work that tie the galaxy together in ways we're only beginning to understand. These movements could be responsible for spreading material across the galaxy, influencing the formation of new stars, planets, and potentially life. Beyond their role in cosmic formation, interstellar objects may also offer us a glimpse into the future of space exploration. As humanity looks to expand beyond the boundaries of our solar system, the study of objects like Oumuamua and Borisov could provide valuable clues for future missions. These objects might hold the key to understanding how to navigate interstellar space, how to use natural forces to propel spacecraft, or how to detect life on distant planets. As our technology advances, we may one day be able to send spacecraft to study these objects up close, unlocking secrets about their origins, composition, and role in the broader cosmic landscape. In the meantime, scientists continue to investigate these interstellar travelers, using every tool at their disposal to uncover their mysteries. The upcoming generation of space telescopes, such as the James Webb Space Telescope, will likely play a pivotal role in furthering our understanding of these objects. With its unprecedented sensitivity and ability to capture infrared light, the James Webb Space Telescope will give astronomers the ability to peer deeper into space and study objects like Oumuamua and Borisov in greater detail. It could help us discover even more interstellar objects, some of which may offer new insights into the formation of the galaxy, the conditions for life, and the potential for future exploration. As we continue to uncover the secrets of interstellar objects, we also confront the larger questions of what it means to be human and our place in the cosmos. The study of these objects challenges our understanding of the universe, revealing just how much we have yet to learn. They are a reminder that space is full of mysteries, some of which may remain unsolved for centuries to come. And yet, each new discovery, each new object that passes through our solar system, brings us one step closer to understanding the vast, interconnected universe that surrounds us. As we continue to explore the far reaches of space, the discovery of interstellar objects reminds us that we are far from knowing everything about the universe. With each new object that crosses our solar system, we are faced with more questions, more puzzles, and more mysteries. This constant flow of new information serves as both a challenge and an invitation for scientists and astronomers to push the boundaries of what we know. The idea that objects from beyond our solar system can venture into our space is a relatively recent realization. For most of human history, we believed that the boundaries of the solar system were impenetrable and that our little corner of the universe was isolated from the rest of the galaxy. But with the discovery of Oumuamua in 2017, this notion was shattered. This was the first time we had detected an object from another star system passing through our own, and its appearance opened the door to the possibility of many more objects out there, just waiting to be discovered. Interestingly, Oumuamua's brief and fast passage through the solar system meant that it wasn't around for long, but its visit was enough to spark a wave of research and discussions about its origins and nature. Scientists rushed to study the object, gathering as much data as they could in the short time it was within reach. Its unusual shape, speed, and trajectory quickly raised the question, could it be a natural object, or could it be something else entirely? The fact that Oumuamua didn't behave like any comet or asteroid we've seen before only deepened the mystery. In fact, Oumuamua's strange behavior triggered a range of theories, both scientific and speculative. One of the most notable theories was proposed by some researchers who speculated that Oumuamua might have been an artificial object, possibly a probe or some form of technology sent from another civilization. This idea has generated considerable interest and debate, as it challenges our conventional understanding of what objects from beyond our solar system could be. However, most mainstream scientists remain skeptical of this theory, citing the lack of any direct evidence of artificial origin. But even if Oumuamua is a natural object, its presence challenges our understanding of the universe. The idea that objects from other star systems can travel through our space so freely opens up many possibilities for the future of exploration. Could there be other objects like Oumuamua out there? And if so, how many have already passed through our solar system without our detection? The mere fact that we discovered one interstellar object has led scientists to think about the probability of others existing, and how we might detect them. In the case of Borisov, we had a much clearer idea of what we were dealing with, since it behaved more like a typical comet. Its discovery gave us a unique opportunity to study the composition and structure of a comet from outside our solar system. And while Borisov didn't present the same kind of mystery as Oumuamua, it still raised profound questions about the nature of the objects that populate other star systems. What can we learn from a comet that has never been affected by the Sun, as comets in our solar system have been? Does this provide insights into the conditions of other parts of the galaxy, perhaps offering clues about how comets and planets form in other solar systems? Despite the differences in their behavior, both Oumuamua and Borisov serve as reminders of the dynamic and ever-changing nature of the universe. Our understanding of the cosmos is constantly evolving as new discoveries force us to rethink old ideas. The study of these objects has opened up a new field of research that looks beyond the confines of our solar system and into the vast expanse of interstellar space. With each new interstellar visitor, we gain a better understanding of how the universe works, how it is structured, and what role our own solar system plays within the grander scheme of things. But even with all the exciting discoveries that have been made so far, the true potential of interstellar objects remains untapped. The idea that we may one day send a spacecraft to explore one of these objects up close is both thrilling and daunting. Such a mission would require groundbreaking technology and unprecedented resources, but the rewards could be immense. By studying an interstellar object in person, we could gather data that would be impossible to obtain from a distance. We might uncover information about the composition of the object, its age, and its history. We might even learn things about the interstellar medium itself, the stuff that fills the space between the stars, that we've never been able to observe before. Currently, there are a number of different space missions under consideration that could potentially explore interstellar objects in the future. Some scientists are looking into the possibility of using the same kinds of technology that have been used to send spacecraft to distant planets in our solar system, such as ion propulsion or solar sails, to reach these objects. Others are exploring the idea of using telescopes, or even flying robotic probes to observe interstellar objects from a safe distance, gathering data about them as they pass through our system. No matter how it's done, one thing is clear: the study of interstellar objects is poised to revolutionize our understanding of the universe. Each new discovery expands the possibilities for what we can learn about the cosmos. With more advanced technology and a growing interest in the subject, we can expect to see many more interstellar objects passing through our solar system in the future, and will likely learn more from each one than we ever thought possible. It's also worth noting that the discovery of interstellar objects challenges our understanding of how the galaxy operates on a larger scale. While these objects are rare, they are a direct reminder of the vastness of space and the movement of material between star systems. The study of interstellar objects raises important questions about the formation and evolution of stars and planets. Are these objects remnants of planetary systems that have been destroyed? Are they rogue planets, or fragments of larger bodies that were torn apart? Understanding these objects can help us learn more about the life cycle of stars, and perhaps even about the possibility of life in other parts of the galaxy. The study of interstellar objects also has implications for our search for extraterrestrial life. Some researchers believe that objects like Oumuamua and Borisov could carry clues about life beyond our solar system. If these objects originated from star systems that are far older than our own, they might have experienced different conditions that could provide insights into how life might develop in other parts of the universe. While the objects themselves may not contain signs of life, their composition and the conditions under which they formed could provide valuable clues about the broader question of whether life exists elsewhere in the cosmos. The discoveries of Oumuamua and Borisov are just the beginning. As our ability to detect and study interstellar objects improves, we will likely uncover even more mysteries about the universe. The study of these objects is just one piece of the larger puzzle of understanding the nature of the galaxy, the cosmos, and our place within it. And as we continue to push the boundaries of exploration, one thing is certain: the more we learn, the more we realize how much there is still to discover. As we continue our journey of exploring the mysteries of interstellar objects, it's important to recognize just how much these discoveries have expanded the scope of our curiosity and understanding. We've barely scratched the surface when it comes to understanding the true nature of the universe beyond our solar system. The discovery of Oumuamua and Borisov opened an entirely new frontier in astronomical research, and as technology improves, we will likely find many more objects from other star systems passing through our own. Each one of these objects is a potential key to unlocking even more secrets about the cosmos. Let's take a step back and consider the implications of what these objects represent. The fact that interstellar objects can make their way through space undetected by our current technology until they get quite close to our system raises intriguing questions. How many have passed by us unnoticed? How many more are out there, hiding in the vast emptiness of space? The sheer numbers could be staggering. Scientists are now beginning to consider the possibility that our solar system is actually much more connected to other star systems than we once believed. Before the discovery of interstellar objects, we thought of our solar system as a largely isolated entity, with limited contact with the rest of the galaxy. The discovery of Oumuamua and Borisov, however, suggests that objects from other star systems are regularly passing through our solar system. It's likely that we've simply missed countless objects in the past, as our ability to detect them is still in its infancy. In fact, the discovery of these objects is only the beginning of a whole new chapter in space exploration. What we once thought of as isolated space is now understood to be a vast, dynamic network of interstellar material, with objects constantly moving between star systems. This realization opens up a range of possibilities for future exploration. For instance, we might one day be able to catch a glimpse of an interstellar object from a star system that is light years away, allowing us to study material that's never been touched by our sun's rays. Let's think about the potential of what these objects could tell us. The composition of interstellar objects could be radically different from those in our own solar system. While comets and asteroids in our solar system have been altered by our sun's radiation and the gravitational forces at play in our system, interstellar objects are pristine. They come from completely different environments, places where the conditions are unlike anything we know. This makes them prime candidates for studying the raw building blocks of the universe. The fact that these objects are from other star systems means they've traveled unimaginable distances to reach us. The journey they've taken is a testament to the vastness of space itself. But it's also a reminder that space is constantly in motion. There's no true stillness in the universe. Stars are born, die, and move through space, taking objects along with them. Even our sun isn't a stationary point in the universe. It's moving through the Milky Way galaxy at incredible speeds. As a result, it's inevitable that objects from other star systems will pass by our own from time to time. Oumuamua's visit was an especially exciting moment in this field of study. Not only was it the first known interstellar object to pass through our solar system, but it also came with a series of peculiarities that set it apart from anything we had ever seen before. The object's odd shape, its unexpected speed, and the mysterious acceleration it experienced as it moved through our system, all of these factors left scientists scratching their heads. Theories about its origin, nature, and even its purpose, whether it was a natural object or something artificial, became the subject of intense debate and fascination. Despite the initial mystery surrounding Oumuamua, it was quickly recognized that these types of objects could hold crucial information about the universe. Even if we never fully understand the nature of Oumuamua itself, the data we've gathered from its encounter has already helped us refine our search for similar objects in the future. We've developed new techniques for tracking and studying these interstellar visitors, which will only improve as our technology continues to advance. But the scientific implications of these discoveries go beyond just the objects themselves. The fact that interstellar objects can travel between star systems means that material from one system can mix with the material of another. This suggests a much more interconnected universe than we ever realized. These objects could, in some ways, be the cosmic equivalent of cosmic dust, traveling between star systems and exchanging material along the way. Could there be life on some of these objects? Could the material carried by Oumuamua or Borisov have played a role in the development of life elsewhere? We may never know, but it's questions like these that keep scientists excited about the endless possibilities. The discovery of interstellar objects has also influenced the way scientists think about the future of space exploration. While it's true that we've only just begun to study these objects, the future holds the potential for much more in-depth research. As technology advances, we may one day be able to send a spacecraft to one of these interstellar objects to study it up close. This could be the next big leap in space exploration, akin to the Voyager missions that visited the outer planets. A spacecraft traveling to an interstellar object would be a mission of unprecedented scale and ambition, and the data collected would be invaluable for understanding the makeup of other star systems. But beyond that, the study of interstellar objects forces us to confront larger questions about the nature of the universe. It reminds us that the universe is full of surprises, and that even our most basic assumptions about space may need to be reevaluated. Just when we think we have a good grasp on the nature of things, an interstellar object passes by and challenges everything we thought we knew. The universe is vast, mysterious, and unpredictable, and the study of interstellar objects is just one of many exciting frontiers awaiting our exploration. As we continue to look outward and search for more interstellar objects, it's important to remember that this is just the beginning. Our understanding of space is evolving constantly, and as we improve our methods of detection and observation, we will inevitably make new discoveries. Whether these objects are natural or artificial, whether they contain the building blocks of life or just cosmic dust, they serve as a reminder of the infinite mysteries that await us in the vast, dark expanse of space. The study of interstellar objects is more than just a scientific curiosity. It's a window into the universe itself. It invites us to question everything we thought we knew, to explore new frontiers, and to consider the vastness of space as we search for answers to the most profound questions about existence. With each new discovery, we edge closer to understanding the universe, not just the objects within it, but the very nature of the cosmos itself. As we continue to look ahead at the study of interstellar objects, we are reminded of the incredible potential they have to reshape our understanding of the cosmos. Each passing object presents an opportunity to learn more about distant star systems, the forces that shape space, and the fundamental building blocks that make up our universe. But as we continue to observe these interstellar visitors, new mysteries arise, and new questions demand answers. One of the most intriguing aspects of studying objects like Oumuamua and Borisov is the way they behave as they pass through our solar system. For instance, the unusual acceleration observed in Oumuamua as it sped through our system has sparked a variety of theories. While initially scientists thought the object was simply a comet, its non-comet-like features, such as its lack of a visible tail or the typical gas emission seen in comets, led to speculation about its true nature. The way it changed speed as it passed through the inner part of our solar system raised even more questions. Was this acceleration caused by the pressure from sunlight, or was there something more exotic at play? Could there be a hidden mechanism inside these objects? Could they be artificial? The idea that interstellar objects might be engineered, either by alien civilizations or as part of some natural process we don't yet understand, challenges our conventional understanding of the cosmos. It's an uncomfortable idea for some, but it's a possibility that cannot be ruled out. The notion that something from beyond our solar system might be a probe or piece of technology designed to study us or gather information is one that has captivated both scientists and the public alike. While most experts remain cautious and emphasize the natural explanations, such as the object being a fragment of a larger comet or asteroid, this doesn't stop the speculation and debate. As fascinating as these possibilities are, the study of interstellar objects also reveals just how much we still don't know about the universe. There's an entire realm of space that's virtually unexplored. While we have our telescopes trained on distant stars, galaxies, and nebulae, we often overlook the objects that come to us, objects that might offer a more direct link to understanding the universe beyond. The next time an object like Oumuamua or Borisov enters our solar system, will we be better prepared to study it? Will we have developed new tools and methods that allow us to fully understand the nature of such objects? Will we have new ways of detecting objects that are on their way to us, even before they get close? Beyond technology, there's also the question of how we can best study these objects once they're detected. Right now, our study of interstellar objects is limited by a number of factors, not least of which is the fact that we can only observe them from afar. The vast distance between Earth and the objects means that even our most powerful telescopes can only give us a limited amount of data. We may have learned a lot from the brief observation of Oumuamua and Borisov, but there's so much more we could discover if we could send a spacecraft to one of these objects for a closer look. In this regard, future space missions to interstellar objects could completely change our approach to studying space. If we manage to intercept one of these objects with a spacecraft, we could study its composition in ways that are impossible with just telescopic observations. We could analyze the material that makes up the object, search for signs of unusual properties, and gather data that could help us understand how such objects travel through space. This could offer clues not only about the formation of the object itself but about the processes that take place in other star systems. It could even provide insights into the early stages of the formation of our own solar system. Of course, sending a spacecraft to an interstellar object is no small feat. The distances involved are staggering, and current spacecraft technology simply isn't fast enough to reach these objects quickly. Oumuamua, for example, was only in our solar system for a brief period, so any attempt to send a mission to study it up close would have had to be planned well in advance. The speeds at which these objects travel mean that by the time we detect them, they may already be on their way out of our solar system. However, advances in space propulsion technology could one day make such missions more feasible. As we look toward the future, it's clear that the study of interstellar objects will continue to play a significant role in expanding our knowledge of the cosmos. We may not yet fully understand the nature of these objects, but as we collect more data and refine our methods of observation, we will be better equipped to answer the fundamental questions about their origins, composition, and significance. It's also worth considering the broader implications of interstellar objects for our understanding of life in the universe. Could these objects carry the ingredients necessary for life? Could they be part of a much larger cosmic cycle in which the building blocks of life are spread from one star system to another? The possibility that life could be distributed across the galaxy through such processes is a tantalizing one. While the discovery of interstellar objects doesn't prove the existence of life elsewhere, it certainly opens the door to the possibility. The raw materials necessary for life may not be as rare as we once thought, and perhaps life could arise in places we never expected. In the end, the study of interstellar objects is an ongoing adventure, a journey that will continue to surprise, challenge, and inspire. With each new discovery, we come closer to understanding the nature of space itself, and perhaps even our place within it. And as we look out into the depths of space, searching for the next interstellar visitor, we can only wonder what other mysteries are waiting to be uncovered. In conclusion, while we've only just begun to scratch the surface of studying interstellar objects, the discoveries we've made so far have already reshaped our understanding of the universe. These objects challenge everything we thought we knew about space, forcing us to rethink the boundaries of our solar system and the interconnectedness of the universe. They remind us that the universe is full of surprises and that our knowledge of it is still in its infancy. Whether these objects are natural or artificial, whether they carry the seeds of life or are simply the remnants of distant star systems, they offer us a glimpse into a world far beyond our own. And as our technology improves and our curiosity continues to drive us forward, we will inevitably make more discoveries, ones that will deepen our understanding of the cosmos and push the limits of what we can know. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.